Hello, everyone, and welcome to GDG DevFest stream. It's our day two, and we are on a track about artificial intelligence and a little bit about Kubernetes. So, if you haven't seen us yesterday, we had a cool introduction with Robert Martin starting our development fest, and now we are on our day two. Stay with us, patch in, and I am introducing Mr. Kaz Sato.
Hi.
How are you?
I'm good.
Okay, so today Mr. Kaz Sato will talk about productionalizing machine learning, and I will give him the word.
Okay, thank you for the intro. Hi, my name is Kaz Sato. I'm a developer advocate based in Tokyo. I have been in Google for like 9 years, and for the last 5 years, I have been working as a Google Cloud developer advocate. So today, I'd like to talk about productionizing machine learning with ML Ops and Cloud AI. So let's get started. So these are the topics. So first, I will introduce what is ML Ops, and then I will discuss how you can build a scalable machine learning development environment for the enterprises. Then we will learn what are the gaps between POC system and production system, and how to fill the gaps between how to fill the gaps by using the cloud AI tools. Then I will discuss why it is important to apply the data validation and model validation for the production systems. And lastly, how to build the machine learning lifecycle management practice. So what is ML Ops? I started discussing the ML Ops like 3 years ago. The first my ML Ops session was held at Cloud Next San Francisco 3 years ago. And I wanted to discuss about this topic because I learned so much from the senior data scientists and software engineers at Google, who has been operating one of the largest machine learning production system at Google for like 12 or 13 years. And he said that launching the machine learning system is the easiest part. The hardest part is keep operating that system for many years. The real problems with the machine learning system will be found while you are continuously operating it for the long term. So we thought the practices we have learned with DevOps area can be also applied to the machine learning system. What is DevOps? It's all about unifying the software development and the software operation by utilizing the automation and the monitoring at the software construction, integration, testing, and releasing the deployment to the infrastructure. And many people misunderstand that ML Ops is only talks about the operational tools and practices, especially the machine learning pipelines. But the operation ops is only a part of the ML Ops story. Because if you think about what's the DevOps, it's all about dev, not only the ops. It's a transformations of dev process to be specialized and optimized for the building production quality ops team, ops infrastructure. So you can apply the same practice to the ML machine learning system. ML Ops is for unifying the machine learning development and machine learning operation. So it requires the collaboration between the data scientists, researchers, ML engineers, data engineers, and ops team, not only the thinking about the operation system. And the main tools for the ML Ops is to unify the automation and the monitoring for the machine learning systems from the construction, building, designing the machine learning models, and integration with the other IT systems, testing and verifying the behavior of the machine learning system, and deployment. And topics I will cover will be based on these two papers. The first paper is Machine Learning, the High Interest Credit Card of the Technical Debt. This publication is written by the the software engineers at Google, who has been operating Google's one of the largest machine learning production system for many years. And there's another important publication is Rules of Machine Learning Best Practices for ML Engineering. So let's get started with the first topic, which is how to build a scalable machine learning development environment. Because you may want to avoid this anti-pattern, depending on the ML superhero. I have seen this kind of the ML superheroes in past projects and customers. An ML superhero can be an ML researcher who can read and understand all the machine learning papers, and also they can be data engineers who can work with the data warehouse, BigQuery, SQL, or Apache Spark, or Hadoop, and anything for the ETL, ingesting data, or pre-processing for the large-scale data set. And also, they can be an infra and ops engineer with the skill set of the container-based infrastructure, Kubernetes, and everything. And superhero can also be a product manager who can define what's the requirements and specification of the product based on the machine learning. And the superhero can explain what's the benefit and business benefit they can get with the machine learning models. Explain to those stakeholders and executives in the corporation. And they have to do that from POC production. So in the early phase of the machine data science, those ML superheroes did a great job on introducing the machine learning into the enterprises and the organization. But from now on, it doesn't scale, because in large enterprises, maybe there could be maybe one or two machine learning projects can be launched with the ML superhero, but there could be like a 5 or 50 or 500 different machine learning projects that could be required for a single enterprise, and it doesn't scale with a couple of ML superheroes. Instead, you have to split the role into multiple roles to build a scalable ML AI team. The multiple roles would include a data engineer, data scientist, ML engineer, developer, and business analyst, and so on. So that you can split the roles, split the responsibility into different roles. For example, data engineer should be responsible for ingesting the data from data warehouse or Google Cloud Storage and apply some preparation, data cleansing, and large-scale pre-processing for the training data. Whereas data scientists can focus on designing and training a machine learning model and get higher accuracy with that. And ops engineer can be responsible for building a continuous training ML pipeline or continuous testing and the analysis infrastructure and deployment and operation infrastructure with monitoring and alerting. So let's think about one scenario where a data scientist is visiting a cubicle of ops team to ask bringing his POC notebooks machine learning model into the production system. So ops team now have to think about how they can build a machine learning platform that could be shared with the data scientists and ops team as well for the production scale usage. And there's another anti-pattern you may want to avoid at this stage, a black box anti-pattern. And this is not the black box problem you'd have in the machine learning model itself. It is also can be a problem that if you train a deep learning model and nobody understands the behavior and nobody can explain or interpret the behavior of the machine learning, that is becoming the hot topic, like explainability of machine learning. But this is not about that. This is more about the communication between the researchers and ops team. For example, researcher would design and train a machine learning model and pass it to the operation team. And the ops engineer would take that and build the infrastructure for the prediction at scale. But that sometimes happens that nobody understands everything. So, for example, researcher doesn't understand what's happening how the production infrastructure works. At the same time, the ops engineer don't understand what's happening in the model itself. So you may want to avoid that, especially for avoiding the emergency troubleshooting situation. So at Google, a hybrid research approach where engineers and researchers are embedded together on the same teams. This practice has helped reducing the source of friction significantly. So how do you share on the same machine learning platform with data scientists and ops engineer? Any good machine learning platform there? One solution could be using a cloud services instead of the on-premise devices that is set up and installed with the data scientists by themselves. One solution or product you can introduce here is the cloud AI platform. So the reason why we provide the AI platform with the multiple components like these the functionalities is to provide the production quality, scalable and available platform for development and deployment of the machine learning systems. AI platform includes multiple components and functionalities, includes the data labeling services, or deep learning VM images, or deep learning container images that I'll be talking about later. And also there's a managed Jupyter Notebook service called AI Platform Notebook, and Kubeflow pipelines for the ML pipeline, training and predictions. Those are the managed services for the large-scale training and prediction. And those components or functionalities are easily can be integrated with the other Google Cloud services like BigQuery, Dataflow, Dataprep, Dataproc, Data Studio, and so on. Another product name I want to introduce here is the TensorFlow Enterprise, which is a commercial version of TensorFlow that is fully optimized for the Google Cloud in terms of the performance and also the technical support. So to understand what are the benefits by using the AI platform and TensorFlow Enterprise, let's think about another scenario where the data scientist is visiting a cubicle again and asking the ops teams to get the GPU machine with everything installed, like CUDA drivers, TensorFlow, everything's maybe by noon. But for ops team, it's really hard to take that kind of the request from the data scientists because in the past, usually there are no standardized software stacks. There's no standardized practices for procuring the data GPU servers and manage them at enterprise scale. So there are many gaps or the challenges the ops team have to solve. For example, the on-premise GPU servers are really expensive to buy, and also it takes a couple of weeks. So procurement itself is very hard. And also software installation should be managed with a software standard stack if you really want to get the professional technical support from ops team. Instead, in early days, data scientists would take their own time for installing a CUDA driver, TensorFlow, NumPy, Plotly, Jupyter, and so on. I remember it was about 3 years ago when I tried to install the TensorFlow with the latest version. I installed the CUDA driver on the computer engine instance at first, then installed the TensorFlow versions. Then I found that the latest CUDA driver is not compatible with the latest TensorFlow version. So you had to install the CUDA driver with a previous version. So that kind of things should not be responsible for the data scientist. Instead, you have to standardize what is the best software stack for the data scientists in an enterprise and package them so that the ops team can easily provide a technical support at scale. And also there's an over-provisioning problem of GPU resources. One data scientist would need 8 GPUs right now to finish the large-scale image training job. But other data scientists would forget about the GPU servers they own because their project has finished many times ago. So that kind of the problem should be avoided. And also, if you want to get the professional technical support from some technicians or engineers at ops teams, you have to standardize everything from softwares and the hardware or virtual machine instances. So the standardization is the key for the large-scale machine learning development environment. One solution we can introduce here is the Deep Learning Virtual Machine, or DLVM, of TensorFlow Enterprise. That provides a standardized virtual machine image for data scientists. So everything like a CUDA driver, NumPy, scikit-learn, Jupyter Notebook, and TensorFlow 1.15, 2.1, or 2.3, or even PyTorch has been already installed in the virtual machine images. So you don't have to spend much time on installing them and struggling with the incompatibility issues by yourself. Instead, you can just go to the console and open Computer Engine console and specify the deep learning image, virtual machine images to create a new instance with GCE or AI Platform Notebook, so that there will be no over-provisioning problem, because by using the Computer Engine or AI Platform Notebook, you have to pay for what you have used on the cloud. You can just stop your instances while you are not using that, and it doesn't cost much. And also you can get other benefits from the cloud environment, such as the preemptible GPUs. Preemptible GPUs is lower priority GPUs. So it's possible while you are using preemptible GPUs, maybe that GPU instance can be shut down abruptly, maybe a couple of times a day. So it's not so useful for the interactive use case for the data scientists. But if you are using the GPUs just for the batch training with the large-scale image training, that takes like many hours or a couple of days. Maybe preemptible GPU is the best solution for that, because the cost of the preemptible GPU is 1/3 of standard GPUs, so that it provides the higher cost efficiency, cost performance ratio. And also, because it's cloud, you can also get the benefits from the specialized processors like TPU, Tensor Processing Unit. That is an AI processor developed by Google that provides the higher cost performance ratio compared to the standard GPUs. Let's take a look at some video to learn how you can use the DLVM with Computer Engine instance. So first, you have to go to the console for creating the virtual machine instances, and then go to the marketplace and look for a deep learning VM and choose that. Then you can specify any number of the virtual CPUs or GPUs you want to use, and choose the TensorFlow Enterprise version, like 1.15 or maybe 2.3, so that you can click the deploy button and create a new DLVM instance in a couple of minutes. So that's it. You don't have to spend half a day for installing the CUDA drivers on TensorFlow by yourself. And another product I'd like to introduce here is the AI Platform Training. That is a managed infrastructure for training the model at scale. So as long as you are training small models that only takes like 1 GPU or 2 GPUs, maybe it cannot be a problem. But if you want to train large models with like 8 GPUs or maybe 16 GPU nodes or more than that, like 50 or 100 GPU nodes, then this is the product for you, because it provides the large-scale distributed training environment as a managed service. So usually, if you want to build this kind of large-scale distributed training environment, you have to hire another professional who knows how to build a cluster of GPUs, how to split the training data into the multiple GPU nodes, and build the so-called data parallel distributed training for the training job. And it takes so long time and cost for building that environment. Or maybe other option could be buying expensive GPU servers like NVIDIA DGX2 or DGX1. That would cost like $400,000, expensive. Instead, you can get started with the AI Platform Training. That provides the scalable, large-scale training environment, but you only have to pay for the time you have used, just like a couple of hours with the tens of GPUs. And also, this training environment can provide the state-of-the-art and automated hyperparameter tuner that has been used in in the Google for many years. This is based on Google's internal hyperparameter tuning tool. So that are the solutions we can introduce to build a scalable machine learning development environment. So how about the production serving or deployment infrastructure? For example, there could be multiple problems like portability and scalability. So data scientists would ask ops teams to support 10 million users based on the POC notebook code written by data scientists. Maybe you can do that if you can add 100,000 lines to that to make it production ready, because there are many gaps between the POC code and production code. Many POC notebooks can be dependent on a local environment or some specific person. So you always have to ask that data scientist just for going through all the processes written on the notebook. Instead, the production system should be portable and shareable with the multiple people in the ops team. And also, in POC, you can always work with a single notebook instance. But for production, you always have to handle the multiple instances running in parallel and having a scaling out or scaling in mechanism based on the workload you are having right now. And load balancing is also important. For example, if you want to expose some the APIs for the image prediction, that API could take like 1 request per second or maybe 1 million requests per second. So how you can build an infrastructure that can be scalable just like that, so that you always have to have a load balancer to dispatch the incoming request into the multiple instances, and with the auto scaling features, adding more instances if needed or reducing number of instances if needed. And everything should not be dependent on a fragile manual process. Instead, everything should be reproducible. For example, if you are working with the Docker container, you may want to write some Docker file, the script, to make it reproducible to build the production infrastructure. So anyone can just run the Docker file to build the Docker container image. Lastly, monitoring can be an issue because you don't want to rely on a single data scientist to keep watching the machine learning model is up and running for 24 hours for 365 days. So that's not a responsibility for the data scientist. Instead, ops team should be responsible for the setting up a continuous monitoring on the important KPIs or metrics and how the machine learning model is making benefits to the business KPIs. And also the alerting mechanism could be required. So another product I can introduce here is AI Platform Prediction. That is another managed service from AI Platform for the online or batch prediction. This provides the auto scaling feature inside it. So based on the traffic or request workload, it automatically adds more and more servers. And also, if it is seeing a decreased traffic, then it automatically reduces the number of the instances. And also, everything can be logged into the BigQuery. So for ops team, it's much easier to build a continuous monitoring setup with BigQuery. And it supports the NVIDIA T4 GPU instance. So rather than using the expensive B100 GPU or CPUs, T4 could be the choice for the prediction workload instead of the training workload. And everything is built on the Google Kubernetes engine or GKE. Usually, if you work with the container environment like a GKE or Docker runtime, then you have to hire a ops engineer who has knowledge and experience on the Kubernetes engine. But actually, to start using the prediction, AI platform prediction, you don't have to hire the cutting-edge GKE engineer because everything is managed by Google. It's a managed service running on the GKE. So, and as an example, let's take a look at one demonstrations where the data scientist would train a scikit-learn model and pass it to the ops engineer to build a scalable platform with the same model. So you can get started with the usual Jupyter notebook environment. At Google Cloud AI platforms, we provide AI platform notebooks as a managed Jupyter notebook environment. So on that notebooks, you can run some SQL with BigQuery to download some training data from data warehouse BigQuery, and use the scikit-learn API for usual data science tasks, like using a pipeline API for defining the training pipeline in the scikit-learn. And you may want to call a fit function to train a model with the pipeline. And then the data scientist can try out some couple of the predictions with test data to make sure that you are getting a proper accuracy with the model. Then you can share the same notebook with the ops engineers, where the ops engineer can upload the trained model to the Google Cloud storage. And then that model can be registered on the AI platform prediction. So now it's production ready because it's running on the AI platform prediction. It is running on the multiple instances on GKE. So you can handle the tens of thousands of requests per second with the same model. So this is how the notebooks can be shared with the data scientist and ops engineer. And transparently, you can make it scalable and available for the production system. And also another option you can take is the TensorFlow Enterprise deep learning containers. Actually, this is exactly the same standardized software stacks for the data scientist. TensorFlow and CUDA driver, NumPy, scikit-learn, and Jupyter notebook, and so on. But the difference is that this is a container image, not the virtual machine images. So this can be used for creating instances for the container environment, like Google Kubernetes Engine, GKE, or AI platform training and AI platform prediction. And for example, the data scientists would get started with the DLVM for implementing the POC notebook or with the Jupyter notebook. Then they can pass the notebook to the ops team, so that the ops team may migrate that DLVM environment to the DLC container environment, because both DLVM and DLC shares exactly the same software stacks. It's much easier for the ops team to migrate the POC notebook into the production container. And what's the benefit you would get by porting everything into the containers? Because you can get all the benefits of the container-based environments, like GKE, like scheduling of the instances, servers, lifecycle management of each instances. They call them as pods in each virtual machines. And the lifecycle management means that you can keep watching if each pod is working properly and ready to take any prediction requests from the load balancer. And based on the workload they are getting right now, so the load balancer or the GKE environment can automatically add more and more pods or reduce the number of the pods. And also the GKE environment has the logging and monitoring tools embedded. Troubleshooting security is already there, so you don't have to spend like 3 months or 6 months to write 100,000 lines of code for make everything production ready. Instead, you can just start using the GKE or AI platform prediction and make it everything container-based scalable production system. And this is a systems architecture example system architecture where you are combining those AI platform components with the other Google Cloud products. For example, for training the model, you can combine them with the other tools such as the Cloud Dataflow for the ETL or data preprocessing, or Google Cloud BigQuery for ingesting data from data warehouse, or Google Cloud Storage can be also another storage. The combined with the AI platform training, that is scalable training environment. And once you have the trained machine learning model, that could be shared on the Google Cloud Storage and used for the serving with the AI platform prediction. So those components you are seeing on this diagram, everything is scalable and available for the production use cases. What about the performance issues? Usually in POC phase, the data scientists are not required to focus on the optimizing performance for the data handling, data cleansing, or the pre-processing. And it should work with the 10,000 rows, but it doesn't work with the 10 million rows. But ops teams sometimes have to handle that kind of the large-scale training data. And maybe ops team could be responsible for training the model again and again, every day or every 1 hour. So ops team is responsible for thinking about getting an optimized performance on the data pre-processing or data training, machine learning training. So the solutions or tools we provide with the TensorFlow Enterprise and Cloud AI platform is the Google Cloud Storage Reader and BigQuery Reader. So TensorFlow Enterprise binary has a special build of TensorFlow that is optimized for the Google Cloud products. So you can get the best performance for reading the data from Google Cloud Storage or reading the results from Google Cloud BigQuery. But data scientists don't have to change anything on existing TensorFlow code like this one. So as you can see, this is the usual TensorFlow code for reading the training data with the dataset API. So you don't have to change anything on that. The one difference is that you can specify the URI of Google Cloud Storage, like gs:// the bucket name and the dataset name, so that the TensorFlow Enterprise binary can detect that and tries to optimize the reading performance with the multi-threaded parallel data processing. And also, you can do the same thing with the BigQuery Reader that provides the client APIs to run a BigQuery query. And when you are reading the results from BigQuery, again, the reading performance is automatically optimized with the multiple thread and the data parallelism, so that you can get the higher performance. For example, for reading the data from Google Cloud Storage Reader, then you could be seeing the almost doubled performance compared with the open source version of TensorFlow. And also by pumping much more training data into the GPUs, you can get higher GPU utilization rate. This is another comparison result that uses the same P100 GPUs for training at the same job with the TensorFlow Enterprise and the ordinary TensorFlow binary. So we have observed almost 30% of the GPU utilization rate increased. And what about technical support? Because TensorFlow is an open source tool, there's no great way to get the professional technical support. The things you can do with the TensorFlow issues is to ask some questions on Stack Overflow and something like that. But with TensorFlow Enterprise, because it's a commercial product provided by Google Cloud, so you can just call Google. You can open a ticket with Google Cloud Technical Support Program and ask some questions and ask for solving an issues with the TensorFlow Enterprise. And each version of TensorFlow Enterprise, like 1.15, 2.1, or 2.3, can be supported up to 3 years. So that was the gaps between POC and production and how to fill the gaps. Let's think about the data and the model validation and why it is important and how to introduce the practice into production. And this is an anti-pattern why you would need the data validation, lack of data validation. What would happen? But think about the usual IT system without machine learning. Everybody is writing millions of codes with programming language like a Python or Java, Go language, anything. And they also write millions of unit testing code for regression test or the unit test to validate the functionality of your system, so that you can make sure your system behaves and expected. Your system's behavior is expected, working as expected. But in machine learning system, The important behavior of your system is defined by data, training data, and machine learning design, model design. How do you validate the behavior of machine learning model and the system based on the machine learning model? Do you write the millions of the unit testing code against the machine learning model? And people don't do that. But you would need some equivalent validation system because data is new code now. The training data defines the behavior of your mission critical system. Another anti-pattern you can see on the production system is training serving skew. Maybe you are working with the PLC notebooks and you are getting the great accuracy with the prototype model. But somehow, if you bring the same model to the serving system, production system, you'll be seeing not great accuracy, or those accuracy will be dropping down gradually. This is the, we call it as a skew. And why this skew happens? Because any differences like distribution of the features in the serving data can be different from the training data, or the way they use for the pre-processing between the training and serving. For example, the windowing for pre-processing against the time series data can be slightly changed. So any slightest difference between training and serving for data pre-processing, data ingesting, cleansing, or the hyperparameters in the training the model, everything can be a cause of the training serving skew. So to solve these production level machine learning the problems, we provide an open source tool called TFX or TensorFlow Extended. This is an open source tool developed by the TensorFlow team for solving that kind of the production machine learning problems. And the yellow components are the open source component right now. So we expect to open source more and more components from the TFX. And the TFX is not a product that is developed from scratch. Actually, it has some successor called Civil. Civil has been a long time and production machine learning deployment framework used in Google for the largest machine learning production system for many years. And Civil has been a proprietary system written in C++. So we decided to reproduce the same quality, same level, scalable machine learning production deployment system as TFX, as open source tool. And now it is available as an open source tool. And many of the large machine learning production system at Google, like a Google Play team or YouTube team, is now actually using TFX. And take a look at each component in the TFX. For example, the TensorFlow DB data validation is one of the important components in TFX. This is a component that helps developers understand, validate, and monitor their machine learning training data at scale. So the many teams at Google are using this tool for analyzing and validate petabytes of the training data every day. So it's a proven technology and product, so that you can easily maintain the health of the production machine learning pipeline. Why TFX team wanted to build TFDB? Because they wanted the users to treat the data errors with the same rigor and care that they deal with the bugs in code. So as I mentioned, data is new code. So if you have any malfunctionalities or any abnormalities happening in training data, it should be found and treated just like the bugs in your code. And actually, the Google Play team was able to introduce the practice of the data validation for the application install feature, so that their application install rate improved 2% for all the applications published on the Google Play platform, after introducing the data validation and finding a state table. Let's take a look at how it works with the data Jupyter Notebook environment. So as I mentioned, this isn't just an open source tool. I'm not talking about any commercial tool from the Google Cloud AI platform yet. So you can just go to the TFX website and download the TFX tools and use it at anywhere because it's an open source tool. For example, in this example, it uses the BigQuery to download the Chicago taxi sample dataset and uses the TFDB to validate the statistics, values, and the distribution of each features of the Chicago taxi training dataset. For example, you can easily drill down into each feature and visualize how the distribution looks like. In this case, payment type has the cash as the primary way of the method for the payment, and credit card and so on. So that you can easily compare the difference between sets. For example, these are two the colors, like one is the brown bar charts and another is gray bar charts. They are the distributions for the training data and the evaluation data set. So if there's any changes in the distribution of the features in each data set, training and evaluation, then naturally you would be seeing the decreased accuracy on the evaluation system. And also you can have some triggers to find the skews and drifts. Skews, as I mentioned, it's a difference of the distribution of the features in different datasets like training and serving. Drift could be changes of the distribution in terms of the timestamp. So you can set up some triggers to detect those triggers and drifts with TFDB in production. Another anti patterns you want to avoid is not knowing the freshness requirements. What is freshness requirements? That is the time intervals to retrain the model again and again. And that is totally dependent on the business requirement. For example, if you are building a news aggregation website, actually I know one of the Japanese customers are retraining the machine learning model every 5 minutes because they really want to take the real-time reflection on the machine learning model for recommending the news on the personalized news page. And also the e-commerce website, like a recommendation system, they may need to retrain the recommendation model every day because the trend of the revenue or trend in the sales of each items could be changing every day. But instead, the contrary, the use cases like natural language processing or the voice recognition doesn't require much higher frequency for the retraining the models, because for example, the voice recognition's training dataset would not change every day. So it's totally depending on the business requirement. You have to define what is the freshness requirement for this particular system. So this is defined as a rules number 8 in the ML paper, the rules of ML paper. Know the freshness requirements of your system. So to do so, the one solution that you can use from TFX is TFMA, TensorFlow model analysis. That is a tool for compute and visualize evaluation metrics of machine learning models. So this is a tool used after the model training, whereas TFDB was the tools used before the training. And you can, with TFMA, you can ensure to meet specific quality thresholds and behaves as expected for all relevant slices of data. What is slices? I will talk about that later. So the easiest use case for the TFMA is compare the accuracy of metrics like ROC for different between different the versions of the models. For example, your model has been working so well until like the last month. But if you take a look at the accuracy of the model trained last week, the accuracy could be dropping down slightly. And if you take a look at the accuracy that is of the model that is trained today, compared with the previous versions, the accuracy could be significantly dropped down. So with TFMA, you can detect this kind of the changes of behavior of your model. And what is slice? Slice means the definition of the segment in a data set. And you can define any arbitrary segment you want to define as slice. The easiest slice you can define is the timestamp, like time of day or day in a week or day in months, and so on. So that you can easily see the difference between those timestamps, day by day or week by week or month by month. Another possible segment could be, for example, demographic differences between the users. So for example, so you can see the difference of the machine learning model accuracy for the Japanese users and the American users and people in the European countries. And also, if you define the slice for the, for example, the age of the users, you can find this model works so well for the children's and younger people, but it doesn't work so well for the elderly people or old people, and so on. So this definition of slices or the TFMA could also be used well for detecting the biases caused by the machine learning model training. So for the machine learning fairness issues, the TFMA can be also a very important tool. Let's take a look at how TFMA works with the Jupyter Notebook. So again, this is an open source tool, so you can just import and use TFMA at any Jupyter Notebook environment. So that you can use the TFMA for visualizing the metrics from your trained model based on the slices you have defined. In this particular example, it is again using the Chicago taxi sample dataset and seeing the metrics based on the timestamps. So for example, you are seeing the now the number is count. You are seeing how many rows of data you are able to get for training the models. And then you can check out the accuracy based on the timestamp. Maybe this model is working so well in daytime, but doesn't work so well in the midnight. And you can detect that with TFMA. Okay, that was the importance of the data validation and the model analysis in production. So let's talk about the machine learning lifecycle management. Because in early days of data science, the data scientists would spend much time on building a handmade process for the everything for building the machine learning training machine learning models, like extracting data from some data source and applying some data cleansing, data preprocessing on the notebook with the pandas data frame and so on. And also within the notebooks, he or she will be struggling to write the training the model and deploy it to the some simple serving infrastructures. And that may work even for the production, but it is not robust and scalable for keep operating the production system for many years. Because maybe 1 year after the launch, or maybe 2 years, or maybe 5 years after the launch, the data scientists would get an emergency call from directors. They would be asking you to retrain the model ASAP because your machine learning model doesn't work anymore. And the users found that your recommendation model is not working properly. So that the data scientists would spend much time on retraining the model that is designed like 5 years ago, and you almost forget about everything. So this is not a responsibility for data scientists, actually. They should not do this kind of the emergency planning or the emergency troubleshooting. And also, how about the monitoring? As I mentioned earlier, the continuous monitoring should not be a responsibility for the data scientist. Instead, you have to establish the continuous monitoring setup as a responsibility for the ops team. And the data scientists should work together with the ops team to how they can build the continuous monitoring the setup with the production system. So this is the reasons why we introduced a product called AI Platform Pipelines. AI Platform Pipeline is based on some open source products from TFX and also Kubeflow pipelines. And but this is provided as a commercial managed services running on the AI platform. And this product allows you to build an orchestrated pipeline, just like the combining the different bricks from the Lego. And it works, everything is working on the Google Kubernetes engine. On the Google Kubernetes engine, we run a Kubeflow pipeline. This is an open source orchestration tool with the metadata store that keeps tracks all the history of the artifacts, like different versions of the data sets, different versions of the model designs, different versions of the model training result, and so on. Everything is managed by the metadata store. And also, you can combine the different components from TFX, like a TFDB or TFMA. And you can, you can watch what's happening in each process of the machine learning pipelines with the graphical user interface like this one you are seeing right now. So at each stage of the machine learning pipeline, you can easily check out the status of the data preprocessing and validation, or the status of the feature engineering with Dataflow or BigQuery and so on. And you can watch how the AI platform training and other tools are doing the training of the models in parallel. And what were the metrics you got, or accuracy or ROC with the models, and how are the deployment to the serving infrastructure is going. And also you can easily compare the different results of the artifacts or the metrics from those the models. And you can also combine the different tools from TFMA or TFDB to do the comparison analysis. So let's take a look at a quick video how you can use this tool in practice. So as I mentioned, there's a user interface to take a look at how your machine learning pipeline is working right now. Check out the status of each process. And the result set is called as artifacts. Artifacts means everything includes the versions of the dataset, versions of the model, and hyperparameters, everything. They are managed as artifacts with metadata. And also the important part is the lineage explorer, where you can manage the lineage of different artifacts. For example, if you get the highest accuracy with a certain model, then you can easily make it reproducible, because the lineage explorer tracks everything from to create this particular model, you use this data set, and you use this hyperparameter, and you use this model, and so on. So that was the topics I wanted to cover. In this session, I introduced what is ML Ops and why it is important, why it is different from just building a machine learning pipeline setup only for the ops team. Instead, ML Ops, it is important to collaborate the devs team, like a data scientist and ops engineer together, so that there should be no black boxes in the production and mission critical the infrastructure. And also, not only the serving system, it is also important to build a scalable machine learning development environment that could be managed by the ops team and professional technicians. And there are many gaps between POC system and production, and how to fill that by utilizing the DLVM or DLC for standardizing the software stacks and make it portable for running the containerized, scalable runtime. And also, now data is new code, so you have to make sure your training data is always healthy, and so that you can get the model working as intended by making sure with the model validation. Lastly, the AI platform pipeline may help you to build a machine learning lifecycle management practice in production. So that's it. Thank you so much.
Thank you very much. So that was a great talk, and I just have to say it's, of course, it's quite hard for the first speaker in a track in a day. Just can't help myself to ask. I mean, using using machine learning in practical applications today has become the almost an industrial standard for most applications. So it is a pain to find proper ML ops into the team. What's your opinion? How do we train them? How do we like? It's not like there are a lot of CVs on every other headhunter job desk saying I am MLOps. How do you find those?
Yeah, that is a very the hard questions to answer. But in the past, when I find a great ML ops engineers working in the many companies and clients, I find those people sometimes came from the data science area. So some data scientists are more interested in building an infrastructure because they are interested in having a skill set for writing a Python code to build an infrastructure with the Kubernetes and so on. And some other patterns can be seen where the existing DevOps engineers are interested in learning the machine learning. And you don't have to find the superhero kind of the person who understands everything for the devs or DevOps area and everything is in the data science. Instead, maybe you can get started with the person who are interested in machine learning. DevOps engineer who want to run basics of the machine learning. So that, as I mentioned in the sessions, you can build a team with the professional data scientists and the DevOps engineers, they closely tied together so that they can teach each other. So that it's possible to much easier to grow a professional ML ops engineer gradually.
And what about if the team is like consists not only of data engineers and software engineers and ML ops, but also from mechanical engineers and electrical engineers and so on? Because it's all about application, and most of the applications that are rising right now are in a real field.
Yeah, that is another interesting the viewpoint, because this is not included in this session, but another important aspect or topic is to closer relationship with the domain problem. Many data scientists think that only learning the data science is not enough. Data science combined with the domain expert or the domain expertise is the strongest weapon for the data scientists. So maybe if you have the field engineers or those domain experts in the teams, maybe it's a very great the opportunity for the data scientists for learning the domain problems. Actually, I found some of the greatest achievements found in the DeepMind team or the Google research team can be found in the team where they have a strong combination with those domain experts and data science team, and they learn each other. So domain experts learning about what kind of things you can do with the latest data scientists, and data scientists will be learning what are the exact problem from the domain knowledge, so that they were able to get the best result, like chemistry or biology and industry and so on.
Okay, and the last question, while we have a couple of minutes. So you talked about machine standardization in order to be easier to replicate and to support, and also how it's all covered in Google Cloud Platform. And since the GPU infrastructure is probably one of the last infrastructural part that is still growing rapidly, and with the latest introduction of Ampere architecture by NVIDIA and their effort that they are putting into their Deep Streamer and TensorRT, can we expect a Google platform to provide the ability to effectively use those libraries? Or maybe with introduction of Ampere-based hardware, can we expect falling of the price per hour, or maybe increasing of the processing power within the same price?
Yeah, that is a great question. And if you're interested, please go to the Google search and the search with the keyword A100 and Google Cloud, so that you can get the Google blog post from Google Cloud that explains about the latest release of the A100 processor on the Google Cloud platform. Actually, the GC Google Cloud was the first platform that supported the A100 platform. And now we have the very close relationship with NVIDIA, so that we provide our platform supports the NVLink interprocessor connections so that I think we still only Google Cloud provides provide the Google computing, the virtual machine node with the 16 A100 nodes that is connected together with the NVLink interconnection that is developed by Google. So until now, maybe NVIDIA's platform like a DGX1 or DGX2 was the best way to get the best software stack and hardware stack from NVIDIA. But now the situation is changing. For the newest, the platform, the cloud is also can provide the best solution for you.
Okay, thank you very much. We have so many questions more to ask, but not too much time. And have a good day. And we are switching to our next speaker, Mr. Rashid Dagil. Hello, how are you?
I'm doing good. What about you?
Can I ask you to increase your microphone volume or?
Sure. Okay. Hello. Am I audible now?
A little bit more if you can.
Okay. Hello. Am I audible now?
Yes, thank you. So using artificial intelligence everywhere in the field is sometimes we face ourselves limited to the hardware that we have to carry. But as we all know, by now we have a lot of processing power in our pocket, and I am giving you the room to talk about how to use machine learning on Android platform.
Sure. Hi everyone. And today, as you just mentioned in brief, as the host just mentioned in brief, we'll be talking about how you can superpower your Android apps with machine learning. So if you haven't used machine learning in Android earlier, haven't deployed machine learning to edge devices earlier, no problem. I'll walk you through it, and you will make your first Android app. Oh, sorry. Let me. Okay. Hello. Okay. So let me know if my voice is clear now.
It is, thank you.
Okay. Sorry, I had a bit of mic fluctuations. So now I guess it should be clear. Okay, I'll start back again. So today we'll be talking about how you can superpower your Android apps and deploy the machine learning models you have made in your Android applications. So if you haven't used machine learning in Android earlier, haven't deployed machine learning models to edge devices earlier, no problem. I'll walk you through it, and you will make your first Android app today with machine learning deployed, deploying machine learning models. If you have worked with machine learning in Android earlier, have worked with earlier versions of Android, know about the TF Android support library, then I'll show you better ways to do it with Android 11. So let's get started. Hi everyone, I'm Rishad, and before we start, I've switched on captions from my end, so it would possibly be easier for you all. You'll see them down on these slides. Okay. Hi everyone, I'm Rishad, and a bit about me. I'm currently a high school student from India. I'm also a TEDx and TED speaker. And a part of the things listed down over here, I've often represented my country in international competitions and hackathons, and even won a few. I further love research, so I've published 7 research papers in the field of machine learning and mathematics. Feel free to give them a look. And know more about me, all of my coordinates are at rishit.tech. Feel free to give that website a look. And my socials are also here. If you want to do any discussion, I'm open to it. Okay, so let's get started. So before I start uh, with today's topic, machine learning on edge, how to deploy them in Android applications, I would like to thank Syed Paul, who's a machine learning GD, Khan Leviat from Google, and Hoy Lam from Google, who have helped me in reviewing these slides and putting together a better version of these slides. So let me just tell you a bit about who the ideal audience would be for this talk. It would essentially be folks who have worked on deep learning models. So if you have made a deep learning model earlier, be it Keras or or TensorFlow estimator using TensorFlow estimator high-level APIs, it does not matter. You should have made a deep learning model earlier, or a machine learning model, as you might call it. And developers who are looking for ways to put the machine learning model into a production ready manner. So, well, if you have made a machine learning model, it's not much useful unless it's actually out to the users. So if you want to deploy your machine learning models on Android, this is the right talk you have come to. Okay, so first off, why care about ML in Android? So I'll not talk much about this, so we can get to the cool stuff very quick. But I'm sure all of you know how the number of Android devices have increased exponentially. I'll be giving you no numbers. I already know all of you are aware about how the number of Android devices have increased exponentially, and are probably also aware of how machine learning is revolutionizing almost every industry. So it makes sense to make this power of ML available to everyone. And how do you do that? Well, you deploy them on mobile devices. We already use products like Google Photos, Gboard, Prisma. You maybe also use Gmail, and it's due to ML that these are so powerful. So, about I told you about why you should care about ML in Android, but today a prime concern would be on-device ML in Android. So today we are majorly going to talk about on-device ML due to some reasons, which we'll soon see. And Android 11 has a lot of cool stuff, has a lot of cool new stuff for on-device ML. Most of the developments are related to on-device ML. So let's take a look into what this hype about on-device ML or ML on edge is all about. The idea is to use ML such that, opposed to the traditional approach, I no longer send my data to a server or a cloud-based system, which then does the ML and then returns me the outputs. I instead get the outputs or inferences from my ML model on the device itself. That is, I no longer send data to a cloud-based system or some server in general. This also means I do all the pre-processing stuff, data preparation stuff, the inference stuff in the mobile device itself. I don't send it outside the mobile device. Okay, so coming back to the question, some of you might be wondering, okay, Rishit, you told me what on-device ML is all about, but you still didn't tell me why should I care about this. So let's come to that. Why is this something you should care about? So the first thing that would come to your mind is power consumption. I spend a lot of power sending or streaming my data continuously to a server. And sometimes it becomes just infeasible to do so. If you're sending a high quality video stream continuously to a server and receiving inferences from it, it might take up a lot of power. So yeah, it's something you should be considering. But yeah, also worth a mention, this is not true in all cases. If you have some heavy pre-processing steps, it could happen that the pre-processing steps take up more power than sending to a server and receiving the data. But in most of the cases, this is something you might care about. Another important thing to consider, especially in real-time applications, is the time it takes me to get the output or essentially run the model. So I want to decrease my inference time as much as possible. I want my users to see almost no latency, or do not have much latency, much visible latency. So, well, have if you do the ML on the device itself, you are decreasing the inference time. And this is also expensive in terms of network availability. I guess you might have already figured this out by now. This is if you are doing some real-time application, sending some video to a server, getting the inferences back, it's pretty network expensive. And I should have the bandwidth or the network to continuously send the data and receive inferences from the server. And finally, another thing which I would like to highlight is, maybe you also figured this out, security or privacy, as you may call it. I no longer send data to a server or cloud-based system. I, in fact, no longer send data out of my device itself. So what does that mean? I essentially enforce privacy. There are a couple of more steps you would do, a couple of more things you would do, but yeah, but this enforces privacy since you're not sending data out of the device. So that was about why you should be caring about on-device ML. So now let us see what Android 11 has for you to do all what we discussed. That is performing on-device ML, pre-processing, doing the inference itself, everything. One of the most coolest updates with Android 11 is the ML model binding plugin, or the machine learning model binding plugin, as you may call it. And before I move forward, I would just like you to make a good enough guess from the name model binding. So you can make a fair enough guess from the name model binding that what would the model binding plugin do. And yeah, also you need Android Studio 4.1 or above to be using the ML model binding plugin. So the ML model binding plugin makes it super easy for you to use a TensorFlow model in your Android app. You essentially have a lot less code to write that calls the TensorFlow Lite Android support library. So for folks who have already been using TF Lite Android support library earlier, you will find this super easy. It will just make your writing the code stuff a lot less, and you are going to love this. For the folks who have not used the TF Lite Android support library, no problem. You'll see how you can deploy ML models on it. You can import TF Lite, or you can import a TF Lite model, read the input-output signatures of the model, and use it with just a few lines of code. And you also don't have to convert everything to byte arrays explicitly. So if you have used TF Lite on Android devices earlier, you know that earlier you had to explicitly convert everything to byte arrays. You no longer have to do that with the M model binding plugin. Another thing which I love about the model binding plugin is it makes it very easy to enable hardware acceleration or make use of GPUs and the neural network API very easily. With the model binding plugin, let's say I want to enable GPU acceleration with the model binding plugin. It's just a dependency call and a single line of code away. So if you want to enable GPU acceleration, it's just one line of code you have to add. Isn't that super cool? And you can also do much more with the neural network API in terms of hardware acceleration, and the model binding plugin makes it easy. And of course, with all what we talked about, this will make your development a lot more faster. We just talked about the features you have, the support you have for integrating your models, and this would make your development a lot more faster. You essentially write a lot less code. So let's see how to do this in practice, and we'll also go through an example of it. So the first step, of course, is to import the TensorFlow Lite model with metadata. So Android Studio now has this new option for importing TensorFlow models. Just right-click on the module you want to import the model in. So once you right-click on the module you want to import your model in, you'll now see a new option called TensorFlow Lite model. So once you click on the TensorFlow Lite model, it will give you a window looking something like this, and you can just pass in the path of your TF Lite model. It will import the model for you in a directory in the module called ML. So it will make a directory in the module where you have imported the TF Lite model called ML, and that's where your model will be imported. This will also be the path from where you will be using your model. So I don't know if you can see it clearly in this slide, but under the place where I can write the path of my model, I have a checkbox called automatically add TensorFlow Lite GPU dependencies. So yeah, adding the GPU dependencies is also just a click away over here. So now from my model metadata, so remember me telling you that you would be importing your TensorFlow Lite models with metadata. So once you open your TensorFlow Lite model in Android Studio, in most cases it will be just double clicking on the TensorFlow Lite model. You'll see the metadata. Right? So here you can see a couple of important things which you need to use the model. So you'll see the input-output types, the input-output shapes, the license under which the model is made, and so on. A description of the model, the architecture which the model uses, if the publisher has made it available, and so on. So a couple of important things in the model metadata, which you can also see in Android Studio now. So in this screenshot, I'm using, okay, so I'm making an example in this talk. So what we can do with this is, this will be applicable to other models, but we'll try to deploy a simple model. So yeah, we make something cool while I do the talk. So we'll make something together in the talk, and it will be applicable for the models too. So in this screenshot, I'm using an open source model made by me to classify between rock, papers, and scissors. Rock, papers, and scissors. Yeah. So I just show the camera rock, papers, or scissors, and it should tell me whether I have put a rock, paper, or scissor in front of it. That's the model I've made. And yeah, again, it's well applicable to other models, but we are just taking an example. So we build something while I do the talk. So that's about the model I'm importing. And and in the rest of the session, I'll be calling this model the RPS model, as the name suggests. I'll be using that acronym. Okay, so we imported my TensorFlow Lite model. Let's finally start using the model. So what we'll do now is we'll make something for a streaming inference, which is most probably what you want to do, live image classification, and we'll make an example of it too. So the easiest way to do this would be to essentially use camera X and pass each frame, so each frame from my live video input to a function which can perform the inference. So I'm using camera X, taking in my live video input, parsing each frame from it, passing each of these frames to a function. So in this talk, what I'm interested about is this function which actually does the inference. So let's see how you do the inference, and you'll also see how easy it is to do this. A sample code for this is also seen when you import a TF Lite model, which you can use. So first off, I'll start by instantiating a RPS model, or a rock, paper, scissors model, which I just imported, and pass it with the context. With the plugin, my model name was rpsmodel.tflite. That is my model file name, rpsmodel.tflite. So once I import it with the model binding plugin, what it will do for me is it will create an exact same class, class name called RPS model. So a class of the exact same name would be made for you. So as you can see, you're in this slide too. I have a class called RPS model, and I'm simply instantiating that class. So I'm simply making an object of that class and passing in the context. Once you do this, you need to convert your data into a form which we can use. So we'll convert it into a tensor image. And how would we do that? We'll do this from a bitmap and pass in an image proxy to it. So folks who have used TensorFlow interpreter before, you know that at this stage, we explicitly needed to convert everything to byte arrays. Well, you no longer need to do that. That is all abstracted for you. And I'll simply feed in the image proxy and convert it into a tensor image. So I can use it with my model. So now I have converted my data into a form which is usable by my model. What next? Well, I'll do the inference itself. So let's pass in the data and do the inference. So you can see some code over here. Don't get intimidated by this. We'll take this line by line. So first off, I process the image from my model, which is essentially saying, okay, take this image and give me the inference or the output for this. So I'm passing in the TF image we made just on the line above this and get the outputs from the model. So if you see, these are what we'll get from this is essentially an array of probabilities. So I had 3 labels in this: rock, papers, and scissors. So I'll get an array with length of 3 with the probabilities for each of these classes. And then I'll perform a descending sort on it. So descending sort is just some filler over here because in this application we are creating, we need the user to see the label which has the highest probability. Maybe in some application, I don't know why, but maybe you want to do something like show the label which has the least probability. We'll just do an ascending sort, or show the label which has some other kind of probability, do some calculations. Well, it is all up to you. It's just a simple array. You can do anything you want to do. But in this case, to make things simple, I've just performed a descending sort on it. So saying the label which has the most accurate, which has the most probability, will be the first one, and so on. After this, I also pick the first end results to show. So in this case, I have rock, paper, scissors, just 3 labels. I can show them all to the user. But let's say you are working on more of a real world scenario and you have a model with 1000 labels. Well, if you use you don't want to show the user all of these labels. I just want to show the user top few labels. So yeah, I'm just doing a dot take and picking the top few labels. After this, I want to show the labels finally to the user. I've performed the inference. I've done some sorting and some processing on the outputs. So it can be as I want to show to the user. I'll add the label corresponding to each entry in the outputs and then show it to the user. And that's pretty much what you need. Just a few lines of code over here. And you did the inference and pretty much you did the inference, took in the data, did live inference. And this is how easy the model binding plugin makes it. As you can see over here, just a couple of lines of code. So remember me telling you how easy it is to enable hardware acceleration. So let's say in this example itself, I want to use GPU acceleration. So I had told you 1 line of code and 1 dependency call. So let's see that. So I want to use GPU acceleration. So what I'll be doing is I'll make an options where I specify it to use GPU. So I'm saying model.device.gpu and I'll build it. In the instantiation part of the model, what I'll just do is I'll pass in this options a part of the context as an argument, and there it is. You can use the GPU now. So the model binding plugin also makes it very easy for you to use a neural network API for acceleration and to do even more with Android 11. Uh, and with Android 11, you have a lot of cool updates to the neural network API, like asymmetric int8 weights and a new quality of service API, which just allows you to do a lot more. But I'll leave that for some other talk as I'm running out of time now. So let's talk about the other major development, which is a new ML kit. So I guess a lot of folks here know about MLKit, know about the earlier version of MLKit. But if you don't know about MLKit, I'll just give you a quick brief. So MLKit provides state-of-the-art pre-trained models available for you to use right in your Android apps. It has a couple of uh, a couple of services which you can use. These are some of the services. This year we also have a couple of new services like pose detection and digital ink recognition, and some changes to the existing services which we'll come to. So these are the services you can do very easily with MLKit. So before I move on, MLKit is now available even without having to make a Firebase project. So remember earlier, we used to make a Firebase project and then use MLKit. Well, now MLKit is available to use even without a Firebase project. As I said earlier, a lot of these updates are focused on on-device ML due to the benefits we just talked about. The new ML kit now has better usability for on-device ML. You can do a lot more about on-device ML with the new ML kit. The ML kit image classification and the object detection and tracking now also support custom models, which means you can have just a TF-Lite model along with the state-of-the-art pre-trained models. So you can specify a custom TF-Lite model, make it run on top of the state-of-the-art pre-trained models by MLKit, and that allows you to get a better customizability. So yeah, that's also something cool with the new MLKit. As of now, this is supported only for the image classification and the object detection and tracking models with MLKit. What this also means is if you're working on some generic use case, let's say a specific kind of image classification, you don't need to make a fully blown model right from the data collection to the training to the deploying part. You can just use MLKit. So let's say I'm doing a particular kind of image classification. I can make a TF-Lite model and run it on top of the MLKit image classification model. And MLKit is which makes MLKit the best thing to use if you're working on some generic kind of use case, as I mentioned an example just now. So let's see an example and let's see how to use MLKit in practice. So again, we'll be building something while I give this talk. So this is applicable for other kind of models too, job models too, but we'll be seeing an example. So we build something while I'm doing this talk. So here I build my goal is to build an application which can classify different food items. So I'll first start off by setting the model and specifying the TF-Lite model file for it. So this is the TF-Lite model file I've made, which works as a food classifier. And yeah, it should be added as an asset before you do this step. Say if you want, or you want it to be loaded properly, It should be an asset. It should be added as an asset in Android Studio. So yeah, I've set off my model and specified my TF-Lite model file for it. This TF-Lite model will run on top of the object detection and tracking model with MLKit. So you can customize these options a bit, but you'll not get complete customizability as well. Your model is running on top of another state-of-the-art pre-trained model. So with MLKit, you can customize these options a bit. I have a couple of options to show you as an example of customizing options with MLKit. So first off, I specified the dot set detector mode. So I'm just telling it, okay, I want to use stream mode, which is live image classification, doing all of this in streaming mode. Another example I've shown over here is the confidence threshold. So I'm saying 80% is my confidence threshold. You can try switching around the confidence threshold, see how it works around. But yeah, I can customize these options a bit. So let's get to the part where we actually run the model. Again, don't get intimidated by code. You might see some syntax similar to the previous example here. First off, I process my image, which is essentially doing the same thing, getting inferences. I process my image, and then I have some listeners over here. So which is saying, if I have a non-failure listener, I want to print out something to the debug log. If I have a success listener, so if it is success, my model has seen something from the live video input that, okay, this is a food. I want to want to draw it on the graphics overlay. So that is what I'm doing in the on success listener. And once it is complete, once all of this is complete for a single frame, I want to close my image proxy. So that's essentially what I'm doing. 3 cases: I'm failing, the model is failing, the model has success in classifying what is there on the video input screen, and once it is complete. So another thing to note over here is all of these are essentially listeners. So that is on failure or on success are essentially okay. So these on failure on success listeners are essentially tasks. So you need to attach them for every run. So that is something you would keep in mind, that you need to attach them for every run because these are essentially tasks. And that is pretty much you need to do to work with MLKit and run a TF-Lite model on top of it. Again, pretty easy, just a few lines of code. So we talked a lot about what to do after you have a TF-Lite model. We talked about deploying it using machine learning model binding plugin, MLKit. But let me talk a bit about the TF-Lite model itself. So I'll not talk much about these as these are a bit out of scope, but you can make state-of-the-art models with TF-Lite Model Maker. You can use state-of-the-art models with TF-Lite Model Maker. It's high performance, super easy to use, super easy to get started with TF-Lite Model Maker, and allows high customization too. And yeah, this was also released by the TensorFlow team this year itself. So the models I've made, the rock, paper, scissors model I demoed in this talk was made with the TF-Lite Model Maker itself. So give it a try. And yeah, sample examples of using the TF-Lite Model Maker are also present in the repository for this talk, a repository which I made specially for this talk. I'll be sharing that soon with you. So you can try out examples from that too. Another place where you can find good models is TensorFlow Hub. You can find state-of-the-art, well-documented models on TensorFlow Hub. And remember, we just made a food classification app, I have an example food classification app. So the TF Lite model, the food classification TF Lite model, was taken from TensorFlow Hub. So you can definitely give it a try. And you also get to use models from the community with TensorFlow Hub. So these are not just the only publishers on TensorFlow Hub, but these are the only ones I could fit in a single slide. So you get to use models from the community. I also have a couple of models on TensorFlow Hub. Be sure to check them out. Okay, so enough of talking. Let's get to demos. So here's the GitHub repo for this talk. It has everything which we talked about today implemented. It also has the source code, which I used to create the TensorFlow Lite models. You can take a look at them, and we'll also see a live demo of this. So I'll wait for a minute while you take a screenshot of this or take a note of this URL. What I'll also do is maybe paste it in the chat. Okay. So take a note of this URL. This would, if there's one thing you want to look back to after the talk, it would be this URL. Okay. I've pasted it right here in the chat. You can take it from the chat too. Yeah. So let me quickly switch my screen. Okay. Could you bring up my screen? Okay, good. So let me show you a bit about the model binding plugin, which we just talked about. As I'm a bit out of time, I'll be showing demos for one of the things we made in the talk. So let's talk about the ML model binding plugin. First off, I instantiate my model, pass in the context. What I then do is I create a tensor image. So, and how do I create that? I create that from an image proxy. So I create a tensor image from the image proxy. I then want to get the outputs. So I use the dot process, the TF image we just made on the line above it. I sort it by descending, as I just told you in the slides, and take the top few results from it. Once this is done, I add the output labels and the output scores so I can show them to the user. Okay, so we talked about MLKit, but let's see a live demo of this. Let's see a live demo. So let's hope my keyboard can make a good background. It's pretty much one color, so shouldn't be a problem. Let's put something in front of this. Well, I'm running this demo on my mobile phone right now. Let's put something in front of it. A rock. Let me take it a bit up. Okay, let's see. It tells me, well, it's a rock by around 70 to 80% probability, which is pretty good. Pretty good work that my model has done. So that was a live demo of what we just made. And yeah, I'll again switch my screen. So yeah, I could have showed a demo in an EVD, but what's better than showing a demo on a live stream when it's available? So that's about my talk, all what I had to present. And with that, if I have time, I would love to take some questions, if there are any.
Thank you very much, Rishit. That was very interesting. And I just have to say, the TensorFlow Lite as a tool is quite energy effective and is quite fast if you run it on a proper device that supports it. And we have to remember that today there are more IRM powered computers than every other computer combined. So they are basically the platform for something like that. But you also have to remember that TF Lite doesn't support all the operations of TensorFlow, right? And which means that not all the things you might want to implement on TensorFlow will be applicable to Tensor Lite on a mobile phone. Could you please tell us your opinion on what kind of tasks would be applicable to implement with TensorFlow Lite, and what kind of tasks you think that wouldn't fit?
Oh, so that's actually a great point related by Bilat here. You should know that not all operations on TensorFlow are supported by TensorFlow Lite, and they are constantly working on adding new operations. But let's say you have an operation with TensorFlow which is not supported by TensorFlow Lite, you would essentially have to do something like make the operation from scratch on your own. That worked for me one time. I was trying some unsupported operation. I just made it into smaller operations which were already supported by TensorFlow Lite, and that could work. But yeah, you would need to know that a lot of operations are not yet supported.
And what do you think, like, what kind of models would be your first choice to switch to TensorFlow Lite? What kinds of applications, like real life applications of AI?
Yeah, so one of the things that I think works best with TensorFlow Lite and has the most support is image models. So if you see the model binding plugin has wonderful support for image models now. I am not very sure about other kinds of models, but yeah, the model binding plugin and MLKit have wonderful support for image models. TensorFlow Lite 2 has a great number of things you need for convolutional networks, supported operations for it. So I think to start with, one of the best applications of AI on mobile with TF Lite would be image models.
Okay, thank you very much.
Thank you.
Now, I just have to know that Rishit is still a student of Narayana School. Am I pronouncing it right? Narayana?
Yeah, that's right.
Yeah, and he's already had given speeches to TEDx, and I wish you good luck, and thank you for our support of the community event.
Thank you. It was my
Have a
pleasure.
good time.
And if you have any more questions, feel free to reach out to me on Twitter, LinkedIn, anywhere you find me.
Thank you. And now we have a couple more minutes to our next speaker. I just want to say thank you everyone who is watching us right now, both online and offline after the session. We are welcoming to all the questions. Our next speaker, Aksharkan Izbasarova, is going to talk about video description generation and practical usage. And the questions for her are applicable in both English and Russian.
Hello, can you hear me?
Hello, great, thanks. So I am ready to stream your presentation.
Is sound okay?
Mm-hmm.
Okay. So let's start. Hello, everyone. My name is Aksharkan Izbasarova. This break, I graduated from Nazarbayev University with a master's degree in electrical and computer engineering. So as a part of master thesis, I wanted to do some mix of computer vision and natural language processing. That's why I have chosen this project, video description generation. And today I'm going to show some small part of my master thesis. So here's the outline of today's presentation. First, I'm going to talk about what's video description, why do we need it, and then show steps for feature extraction, then introduce two neural network models, show evaluation metrics used to evaluate the performance of the models, give results, and demonstrate video description algorithm. So what's video description? It's just a generation of text that describes the video content. There are different applications of video description, such as human-machine interface, automatic video subtitling, some surveillance systems, video-to-text processing. Highly efficient video description can be useful in different applications. For example, in surveillance cameras, for example, for automatic detection of the scenery, for generating description of the scenery. With the recent developments in the field of deep learning, there was progress in the video description. However, there is still a significant gap between the accuracy of the currently available methods for automatic video description and the performance of the tasks by human. That's why this task is challenging, but at the same time is interesting. So here's the methodology. So flow chart showing the basic steps for video description. So first we have video input. We need to extract features from the video. Then we have, we should train neural network. And for this project, I used two types of neural network, sequence to sequence and attention mechanism. And then we generate text, like which describes the video. So now let's look at each of these steps. So first step is feature extraction for video. So video basically is a sequence of frames. That's why we use frame to extract features. So for each video, I've used 40 frames. And we pass this frame through the VGG16 network. VGG16 is a very popular neural network that was trained on huge data set, like on data set with about 14 million images from different classes. And it's mostly used for transfer learning, so for feature extraction. This network consists of different layers of convolutional and max pooling with a different number of channels. Since this network was trained for classification, the last layer is softmax layer. However, for our task for video feature extraction, we don't need classification part. So we just pass each frame through the VGG16 network till the last layer. So each frame will be represented by a feature vector of size 4096. So for each video, I use 40 frames, and each frame is represented by a vector of 4096. Next, text. Since we need to train our model to generate text, we should give input in terms of text. However, we cannot input just raw text. We need to preprocess it and give in terms of numerical values. So this process is called vectorization. So for example, we have sentence, kids are talking about the rain. Then we do some preprocessing. We just do lowercase, we remove some extra spaces, numbers, symbols, special symbols, and add this at the end and at this beginning, at the end of sentence, we add these tokens. I will explain later why do we need them. And after that, we do tokenization. So tokenization is a process of representing sequence in terms of smaller parts. So in our case, we use words. So sentence, we represent sentence as a sequence of words, and we give index for each unique word is represented by some index, unique index. So here, for example, this sentence now look like this after tokenization. And then in order to input to the model, we convert to vector. There are two ways. First is to train our own embedding layer, or another method is use already pre-trained Glove database, which has vectors for each word in the dictionary. So after this step, each word will be represented as a vector. And the size of the vector we define by ourselves, by training, by adjusting the parameters. And so our initial sentence now look like this, as a list of vectors. Let's see. So before going to neural network, let's quickly recap some basic LSTM layer. This layer is a special, stands for long short-term memory. It's a special type of recurrent neural network. It's just a chain of blocks. So each block has its own input, hidden states, cell state, and 3 gates. Forget input and output gates. So, for example, at time step T, we have input if X. Then we decide which part of the cell we should forget, which part of the new input we should pass to that cell state, like add to memory. We also generate some candidate cell states, and then we decide which part of the new information we will pass to the next time step, like we'll output to the next time step here. So all of these gates are just some dense layers. So for example, with sigmoid or hyperbolic tangent. And next is gated recurrent unit. It's similar to LSTM. It has also chain of blocks, but in contrast to LSTM, has only reset and update gates. So we have our input at time t, and then reset gate decides whether to remove some part of the previous hidden state here. And then update gate decides whether to add input, how much of input should be added to the hidden state, and it will be sent to the next time step. So for example, when update gate value is 1, the hidden state will be equal to the previous hidden state. And when update value is 0, it means we will consider new input. So here's the first neural network model, sequence to sequence. It consists of 2 parts, like encoder and decoder. Why it's called sequence to sequence? Because from sequence we generate another sequence. So in our case, in our project, input sequence is just sequence of frames, and output is text in terms of sequence of words. So encoder and decoder, they consist of LSTM layers. So we have 40 time steps. So I used 40 frames, and I just have like input them at different time steps. And in the decoder, I also have 40 time steps, because the length of the text of the sentence generated by the model will be 40, like maximum 40 words will be generated. So let's start with encoder. Let's look at encoder. We have our input, like frame 1, frame 2, and we have hidden states of LSTM layer, each LSTM at each time step has 40 units, and then we pass our inputs through the layers and obtain the last hidden state. And this hidden state will be used as input to the decoder. And this hidden state is actually a vector which stores information about the input, our input frames. Remember embedding layer, so we also have text and we need to insert text to our model. That's why we pass our sentence through the embedding layer. So 28,366 is the vocabulary, dictionary size. So it means our model knows only this much of words. And so after embedding layer, we obtain like vectors for our words. So first input to the decoder is always start sequence talking. Because we need to let the model know where is the beginning and end of the sentence. And the last word will be always end sequence. So we have input, and for inference stage, we take the output of the previous time step as input to the next here. V2, for example, generated by the first time step is used as input in the next time step, and so on. And at the end, we have dense layer. So as I mentioned, there are like 28,366 words, and the dense layer decides whether the generated given word belongs to one of them. Just has a softmax activation function for probability distribution. This one is for inference stage, but for training stage, we know our output. We know what sentence should our model generate for the given input, and that's why when we pass input to the decoder, we take them from the labels, from the known sentences, given sentences, reference sentences, not from the hidden state output of the previous time step. And the difference between training and inference stage can be seen here. So here's the code. So for training stage, first we have input. We have 40 frames with size 4096. Then for encoder, we use LSTM with 40 units. Then we pass our input, image input, to the encoder. And we obtain encoder states. Because we need encoder states because we pass the last encoder state to the decoder. So then we have embedding layer. Used 256 units, means each word is represented by a vector of 256. And then have decoder, we define decoder, is also LSTM with 40 units. And here we can see that initial state of our LSTM is actual encoder state. Then we have dense layer with softmax, and we obtain our output. So inputs to the model during training is just images like frames, to be exactly features, image features, then language input like the output of the embedding layer, and output is the output of the dense layer. But for inference stage, we pass not the here for decoder, we pass decoder state inputs, and because we pass the output of the previous time step to the next time steps. That's why we have decoder state inputs here. Here you can see. That's for sequence-to-sequence model. And attention mechanism, attention network is very similar to sequence-to-sequence. It's just some transformation of that because it considers the context vector. So if in previous sequence-to-sequence model we pass inputs and obtain and take the last hidden state of the encoder and pass it to the decoder. In this case, in attention mechanism, we use inputs all the time, like information about inputs at each time step. So, for example, in sequence-to-sequence, only one vector is used to represent input. And sometimes some early frames can be, the information about early frames can be missed, but in attention mechanism, we keep this information. And why it's called attention? Because it means like, it shows how much attention network should pay to the encoder, to the input, in order to give the current output. So we have 40 frames, for example, and first we calculate score. We use outputs of the encoder, like hidden states of the encoder, and hidden state of the decoder at current time t. The score is computed by using dense layers. So we have a separate dense layer for encoder and for decoder. And then we apply softmax in order to have values from 0 to 1. So our attention weights will be from 0 to 1. And then we can calculate context vector. So why from 0 to 1? So if attention weight is 1, for example, for time step for encoder input 4, means that in order to predict current output, the network should pay more attention to the input number 4, and the rest can be ignored. So that's how we calculate context vector, and then we use this context vector and concatenate with the current, with the previous output of the decoder, and obtain new input to the decoder. So and so on. So this information, like for the next time step, we again calculate score, softmax, attention weight, the context vector, and obtain new input. And the main difference also is in the layer that I used. So for attention mechanism, I'm using gated recurrent unit for encoder and decoder. The reason is because attention mechanism requires more training because we have additional 3 dense layers, and gated recurrent unit has less parameters than LSTM. And that's it for the second model. And now here is the code. So how attention unit is implemented. This kind of attention unit is called additive because we add the encoder and decoder hidden states. It was introduced by Bogdanov. That's why it's called after his name. So we have dense layers, and here we just add. So we have values like weights for encoder hidden state, for decoder, and we then train again another dense layer, apply softmax, and we multiply attention weights by the values by encoder hidden states, and reduce sum. It's done to sum up across the time step. So we sum up across the axis 1. In order to evaluate and to know how good our model at generating captions, we should use some metrics. And one of the popular metrics used in evaluation of machine translation is BLUE, bilingual evaluation on the study. This metric just evaluates how close the generated sentence to the reference sentence by calculating the number of matches of n-grams. So, for example, we have our candidate sentence just generated by our model, and we have reference sentence. And we compare them and calculate how many matches of, for example, 1 word, of 2 words, of 3 words, or 4 words between them. Then we calculate brevity penalty, if the length of generated sentence and reference sentence are different. And finally, we obtain BLUE score by using geometrical mean. And so the value of 1 of the BLUE metric means that the generated caption total is totally identical to the reference caption, and 0 means that there are no any words that match in both sentences. The problem with BLUE is that it considers exact matching. So in order to obtain 1 means like the words should be identical. That's why another metric was introduced called Meteor. This metric is considers not only exact matches, but stemmed words, synonyms, paraphrased matching. For example, when we have when two different person describes the video, they can use like different words, but the meaning can be the same. So for such cases, Meteor is more useful than BLUE. And so it also counts matchings. First, we find the number of mapped unigrams. Like by unigrams means word. So how many words in both sentences the same. Then we find precision and recall for generated sentence and for reference sentence. Then find fragmentation ratio. Calculate the harmonic mean. Here, fragmentation ratio is calculated by using chunk. So we divide our sentence like into chunks, fewest number of chunks, where the order of words will be identical. So it is done to evaluate or to penalize the word ordering. For example, in both generated and reference sentences, words could be identical, but the order can be different. So, for example, the generated caption will have no meaning because the order is completely messed. And to penalize such cases, we use this fragmentation chunk. And alpha, beta, and gamma are just the parameters. And finally, Meteor is calculated using this formula. So, and let's talk about the dataset used for training. So, there is dataset presented by Microsoft for this kind of test. So it has more than 10,000 of videos from YouTube. They are very short, like 10 to 15 seconds, and from different kind of categories. And each video is described with 20 sentences. So for each video, there are 20 reference captions. And when we train the model, we consider these captions, like 20 captions, as separate input to the model. So here's the distribution of training, validation, and test set. So here's the results. So our sequence-to-sequence model, for our sequence-to-sequence model, the best choice of optimizer was RMS Probe. And also I have tried different kinds of embedding layers, tried to use pre-trained Glove dataset and train embedding with 40 of 256 units. And the best blue 4 score was for with embedding 256, and in Meteor score, he is even better than blue score. And for attention networks, the best optimizer was Adam. And also I tried different units. So remember, our attention mechanism consists of different dense layers to calculate context vector. So I tried 10 or 20 units in these dense layers. And the result shows that 20 units performs better. So here, the blue 4 score is the same for sequence-to-sequence and attention network. However, in terms of Meteor score, our attention network performs better. The reason why this happens is because Meteor considers synonyms, paraphrase, and that's why when blue 4 score is small, Meteor is can be higher. Here's the results for the attention network. So this heat map shows for each frame, for each output, like the sentence generated by the model is a woman is shown as stroller. So for each output, what was the attention weight of the frames? Like which frame was like more important in generating this output? So for example, here I have frames. I haven't put all the frames, just some of them from frame 0, then 29, and to 39. And for example, for word woman, we can see that frame 0 is small. The attention weight value is small. But when it comes to frame 31, attention weight slightly increases. And from the images, we can see that at frame 0, we can't see woman, like she's faded. But then by frame 31, we can clearly see woman. So it means when the model predicted word woman, paid more attention to these frames, frame 31, 32, 39. And for example, for word stroller, it paid more the highest attention during frame 0. Let's now look at the video, and I will show the sentences generated by both models. So just there's a person showing how to fold a paper, and his reference caption, the person is folding paper, and the results of sequence-to-sequence model, the person is folding a piece of paper, and attention network gave similar results. A person is folding a paper airplane. So we can see that both sequence-to-sequence and attention networks, they generated the sentences which are correct, but slightly different from each other, but the general meaning is the same as in reference caption. And next video. So this video and reference caption is woman showing how to cook. By the way, I need to mention that the dataset itself, the reference captions, can be wrong. They have some misspellings. They can be grammatically incorrect, and but we can see that even though the reference caption can be incorrect, our models generated the correct result. But for sequence-to-sequence model, we can see that the result is not that good. It's given like a woman is talking about a man. So yes, a woman is talking, but not about a man, about the food. So it's not correct. But attention network generated answer, a woman is cooking, which is correct. So by this example, we can see that attention network performed better and it gives better results. So to conclude my presentation, so two network types were introduced, sequence-to-sequence and attention network. They are very similar in terms of architecture, but attention network considers inputs, encoder inputs during generation of output by using attention weights. And we can see that, and we saw that attention network has demonstrated higher meteor score compared with sequence-to-sequence network. And for the future work, I think this task can be improved by the performance of this task can be improved by introducing multimodal network, where we process not only images like I did today, but audio too. So by adding like audio, we can maybe improve the performance of this task. Here's the references. So thank you. If you have any questions, I will be happy to answer.
Thank you very much, Akzarkan. That was quite interesting. So the practical application of video description today is, well, hard to underestimate because there are so many videos shooting right now to CCTV cameras, security cameras all over the world. All the things that we shoot on our mobile phones every other day, and how much trouble it takes for us to find the proper video in our cell phone's album when we want to see some video of our kids among all other videos of us shooting fireworks that we never watch again. So the big question about is, since attention network allows to get better results, what about power consumption? Because it's on this scale, power consumption matters. What do you think about it?
Yes. So first, since attention network is more complicated than sequence-to-sequence, it can consume more power. But I tried to simplify it by, for example, changing the LSTM into gated recurrent unit, which has less parameters. So it means we just decrease the calculation. And also I try to minimize the number of units. So generally in papers, they use like in each gated recurrent unit, at each time steps, they use about 256 to 512 units, but here I use only 40 units. But yes, I think this model should be further optimized for edge devices like mobile phone. In this project, I tried it only on computer. So I think for mobile device can be, yes, need some optimization to decrease power consumption.
And also one more question before we move to our next speaker. is about the complexity of preparing and training the model. Because as you mentioned, you've used a lot of images in order to train the attention network. And it might be challenging for certain applications to collect that kind of data set. What would you recommend in order to prepare the data set, and how full should it be? How big should it be in order to perform the way you showed us?
So the advantage of the dataset that I used from Microsoft that it has all kind of data, kind of video from different categories. But if we're doing it for example, for specific tasks, for example, for videos about cooking, so our dataset should be subject specific. So it depends. First, we should decide why do we need this video description. And second, the quality of the reference captions matter, because as I mentioned, even this dataset was prepared by Microsoft, the quality of reference captions were not so good. There were a lot of misspellings. There were some, as I said, that per one video there are 20 captions, like means they were captioned by different people, like person, and some of the captions were totally irrelevant. And so I think a lot of attention should be paid on the structure of the sentences, so the training can be better and easier.
Okay, thank you very much. And just a second. Yeah, well, thanks for joining us. Have a good day, and we will shift to our next speaker.
Thank you.
And our next speaker is Mr. Randy Gupta. Welcome. How are you?
Hello, Bulat. I'm fine.
I'm quite fascinating to see like big names that I've heard about like years and years ago, and I'm quite happy to have you here. You have a very impressive biography. I hope you would share with us this experience. And since we are talking about artificial intelligence and cloud platforms and so on, Mr. Randy Gupta will give us some introduction to Kubernetes, which is, as you might know, orchestration platform for containers like Docker images. And if you don't know what a Docker image is, then you probably should know that by now. Just go and study that. Now, I'm giving to you the platform.
Thank you. First of all, I will give a short introduction about, or a short overview of the history of Kubernetes, because that helps a lot to understand what Kubernetes is and what Kubernetes does. So Kubernetes is actually a fork of Borg, which is a container platform used by Google internally. They are still using Borg, but Borg is very specific to the needs of Google. And Kubernetes is, can be considered as the open source version of Borg. So let me start with the data centers. So that is not how the data centers in the mid-90s looked like. They looked more like that. So that was, this is a picture of a real rack, which has been used for by Google in the very beginning. Google didn't have much money to buy expensive server hardware, and so what they did was they took the cheapest hardware where they could get. They left everything away, including the housing, including power switches, and they have put everything into the racks as much as possible. Usually, you have in a server rack, you have per row you have one server. They have put in 4 servers by putting just the main board inside of it. And if you look at the picture here, you can see they have isolated the main boards with cork, and so that it doesn't cause any shortcuts. At least that was the try. In fact, many of this hardware did never work. So that means they needed an intelligent software to schedule the load so that there are only those servers used that are actually working. And if something else got broken, then the software had to be started on an entirely different server. And that was actually the how Borg was born. And Kubernetes, as I said, is a fork of Borg. What you can do with Kubernetes, as initially said, it is a container orchestration platform. But let us speak more about what where you can run it first. You can run it on your laptop, for example. Minikube is a good starting point. If you have Ubuntu running, you can actually start Kubernetes with the package manager. You just run microcates, which is very easy to use. I can absolutely recommend that for Ubuntu users. You can run it on bare metal servers, as I've just shown. Actually, you just need the main boards and a little bit of power. For Kubernetes, there are so-called distributions, like Linux. You can get Kubernetes in different flavors, but the platform itself, the environment for the software is always the same. I will speak about that later on. For Kubernetes, you can get different so-called distributions. My personal favorite distribution for bare metal Kubernetes is Rancher. That makes it very easy to deploy Kubernetes on bare metal machines. All you need to have is SSH access to that, and Rancher spins up on top of that a whole Kubernetes cluster. Another very popular distribution is OpenShift by Red Hat. Red Hat is also actively contributing to the development of Kubernetes, like many more companies like IBM, VMware, etc. Even Microsoft is contributing to that, I think. Then there is K3s, pronounced Kates, and that is for smaller devices like Raspberry Pi, which is also possible to run Kubernetes with. And a very good starting point is also the cloud. Personally, I mostly work on the GCP, where you can start a so-called GKE cluster, the Kubernetes engine cluster, on the GCP, and don't have to worry about anything. You have a fully managed cluster, and then on the cluster you can run microservices, yes, but not only microservices. You can run batch processes, whatever you need to process. You can start a process, and the whole cluster take care of that. You can operate service meshes, where you have a mesh of applications that spans across the cluster. You can, for example, expand that mesh onto your edge devices, on your DC on-prem. The most popular service mesh today is Istio, but also Linkerd is widely used. You can run serverless workloads. My previous talk today was actually about Knative, where you can put a workload into Kubernetes, and if you put an HTTP request on a particular endpoint, Kubernetes will on the fly start the container, reply to let the container reply to that request, and if it doesn't get any new requests, it will simply delete it again. It doesn't consume any resources. That means Kubernetes can also be a platform for serverless workloads. With that, you're not locked into the vendor's offering, like with AWS Lambdas or Cloud Functions. You can even run virtual machines. That is what Kubernetes, what Google does very regular with Borg. Borg is actually running virtual machines. For example, if you need a Windows service or something like that, for whatever reason. You can run machine learning workloads with a Kubeflow. That is also these solutions here that I'm listing here are all Kubernetes native applications. Kubeflow, as the name implies, is TensorFlow for Kubernetes. You can then even get TensorFlow running with GPUs and TPUs, I think, as well. You can run game servers. Agonis is a very nice solution that builds on top of Kubernetes, and there you can use your Kubernetes cluster as a game server. You can also run databases with all kinds of databases. Kubernetes has the concept of operators, which is a software that sits inside the Kubernetes cluster and take care of the lifecycle of a database. For example, if you need to add more nodes, or you need to decommission something or upgrade a schema, the concept here is for databases, you usually have a human operator, and some of these tasks, obviously not all of these tasks, can then be taken over by Kubernetes operators. Basically anything that you can put into a Docker container can be can be deployed into Kubernetes. Actually, I don't have a presentation about Docker here, but in the Q&A session later on, I'm happy to answer questions around Docker itself. If you want to work with Kubernetes, you need to know what Docker is. In a nutshell, Docker images is the Linux userland environment. There's anything in except for the kernel. And if you start Docker, you simply hand over a file system to the kernel and let it run in a sandbox. I hope that is a definition that makes it a little bit clearer. So I have said Kubernetes is a unified environment. Although you can run Kubernetes on pretty every device, so even on embedded devices like Raspberry Pis, you need to be sure, if you develop a software for an environment, that you don't have to take care on where that is running. So that means when you develop for Kubernetes, you have a certified Kubernetes cluster, which, for example, the GKE is the Google Kubernetes Engine is a certified cluster. Amazon EKS is providing certified clusters. Azure is providing certified clusters. Also, the distributions that I've listed before, Rancher, even if you take your own machines, you can have a certified cluster there. And with that, you can be sure that if you develop something on your Minikube, which is also a certified Kubernetes cluster, you can be sure that if you deploy that into another cluster, you will find pretty much the same features. And with that, Kubernetes can be considered as an abstraction to all the cloud vendors. And that makes Kubernetes very valuable. In fact, Kubernetes is the most active open source project, except for one. The only other the only most active open source project is the Linux kernel, and then there is Kubernetes. So that hopefully gives an impression how vibrant the ecosystem and the community around Kubernetes is. Again, it is very important to understand for a cloud strategy. If you build on top of Kubernetes, you have an abstraction on the cloud vendors, and you don't need to be worried that you're locked into the vendor's offering. So I have said that there is a rich ecosystem. First of all, there are a lot of applications for Kubernetes. I mean, basically, you can take any Docker image and toss it into that. However, applications are usually more complex than just a Docker image. They consist of often of multiple Docker images. And a database is a lot of configuration. What you can get here is, and therefore I'm sharing here one offering. Kubernetes comes with a package manager called Helm, and that works pretty much like the package manager on your Linux box, or even on your phone if you install something from the App Store. You're actually using a package manager, and the same concept works also for Kubernetes. This is for example a repository from Bitnami. And there you can choose between all the applications. You can simply take a package here from WordPress, or everything that you find here. You can say simply Helm install Jenkins, right? And then you and that's more or less all it takes to have a full-fledged Jenkins server running in your Kubernetes cluster. Again, it doesn't matter where it is. Of course, Jenkins doesn't work well on Raspberry Pis, but if you have your bare metal machines or you run it in the cloud, you get pretty much the same experience. And that is like own cloud here. And that is very important to understand, that we have here a very, very rich ecosystem, and that is just the offering from Bitnami. Everybody can host its own repository. You can host your own repository for your own software. If you're an enterprise and you don't want to publish your software in the internet, you have your private repository here, for example. So another important part is the developer experience. And if I'm not going to mess up my time here, I will show you how to actually develop an application and deploy that into Kubernetes. for that, we have a Cloud IDE. Actually, it is an IDE plugin. That plugin works with Visual Studio Code or IntelliJ, which I prefer to use for coding. Actually, I use both of them. And that makes it very easy to start with Kubernetes and to deploy your own application. So let me first explain a little bit about the concept of Kubernetes. Kubernetes has the concept of pods. So as we said earlier, we deploy Docker containers. Docker containers are actually processes inside the Linux kernel. You start one process, that process can spawn child processes, but basically you start one process, for example, a web server, Nginx or whatsoever, and that can start then its child servers. And that is the Docker container. A Kubernetes pod is in its smallest version one container inside of a pod. However, usually you also need a file system. You can have the immutable file system in the Docker container, but sometimes also you need to write data and persist the data. Whatever you have in the Docker container is fixed there in the file system, and that won't change, but the Docker container itself can mount an external file system, and that is what is here shown as the violet cylinder here that should represent the file system. And however, you can also have two containers running in one pod. Usually, you do that only to support your main container. For example, I have one application, and I have a microservice, and that microservice doesn't care much about SSL or authentication, etc. And therefore, you can deploy a so-called sidecar container, which is just another container which helps the main container. That takes, for example, all the traffic and acts as a reverse proxy, for example, which is then routing the traffic to the actual user container. That shouldn't be too complex because this is all running on the same machine. These are the smallest entities. Pods, you shouldn't create too big pods. Actually, you should rather create smaller pods and then replicate them. Another concept for a sidecar container is a container that is taking the logs out of that container and ship them to somewhere, to another central place, like Elasticsearch or Prometheus, you name it. So that if you write your application, you don't have to take care of the logging. You just log to standard out and let the sidecar container scrape this information. That's for the pods. Again, a Kubernetes pod is the smallest entity. The normal case is you have here one container inside of a pod. It is important to mention that every container inside of a pod can share the same file system, and they have all an IP address to the external world. So if these two host containers want to talk to each other, they basically speak to local host. They just need to have a different port, right? And they can mount the same file system. That is important to understand. So in the Kubernetes world, Kubernetes is therefore to take care that your workload is always up and running. So let's say I deploy a number of pods into the Kubernetes cluster. And as I've shown earlier, Kubernetes is built to run on very unreliable hardware. That makes it, for example, easy to use preemptible machines from Google or Spot instances, so that you can say, okay, I can take the unreliable machines, which can be taken away from me. Preemptible machines are very ephemeral machines. They last maximum up to 24 hours, but they can be taken away from you at any time. These are more or less spare machines that Google has there to fulfill some service level agreements. If something has to scale out, then they take these preemptible machines away from you. But on the other side, you can get another machine. So therefore, I'm also running production workloads on preemptible machines where I don't have stateful applications. I wouldn't run a database, for example, on a preemptible machine. However, what I can rely on is that whenever one node goes away, I have here in this example, I have 8 pods running. And if one worker node goes away, be it just because the bare metal machine dies or the preemptible machine has taken away from me, then Kubernetes takes care that these remaining pods are started on the other machines. And what you also have inside of Kubernetes is load balancers, which are aware which pod is healthy, and they route the traffic only to the healthy pods. So that means you usually have multiple replicas of a pod, and you tell Kubernetes, don't start them on the same node. And if a node dies, the traffic will then be routed only to the healthy pods. Also, if a pod is unhealthy, because you have some problems inside of the Kubernetes container. Kubernetes detects that when provided you implement the right hooks, so that Kubernetes can understand what how the pod is doing. That these are the so-called health checks. Kubernetes needs an endpoint where it asks, "Hey, pod, are you healthy?" That can be an HTTP endpoint that replies with an HTTP 200. And as long as the pod is replying to that request from Kubernetes, Kubernetes know, okay, that pod can take more still traffic. If it stopped doing that, then Kubernetes assumes this pod is unhealthy, and it will route the traffic to the healthy pods and eventually kill that pod. So, demo time. I can answer some questions in between if you like, or I can continue with the demo of Cloud Run, if you like.
Well, I suggest that we should proceed to the demo and put the questions to the end.
Okay, fair enough. So I take my IntelliJ IDE. So let me start a new project. That is here. I take Cloud Code for Kubernetes. Let me take the guestbook. So that is an example. Yeah, that is. It is asking me here about the Docker image. So when I want to deploy something in Kubernetes, I need a Docker image. So that means when I'm developing here locally something, I need as soon as I'm done, I need to package that into a Docker image and push that to the to the container registry, which is a storage for Docker images, and Kubernetes has access to the registry and can pull that from there. So I call it DevFest, and yeah, where's the best place for that? Content root. Well, let me put that into temp. So actually, I was expecting here a little bit more. It's always the fun with demos. I think I've messed it up when I have changed the path. Okay, let me close that. So let me start it again. Okay, project location. That's where I have broken it. Would you like to override it? Yes. Okay, here I got my code. I have here a backend, which is written in Go. Okay, I should set up root. There's also a front end, which is template, etc. However, I won't go too much into detail into what here the code is. It is important for me. I have here a set where I can start with, and what I would like to show is how I can deploy that to Kubernetes. So let me edit that. So if there is anything important to set, I have here the container registry. I have here my current context. That means I can have multiple clusters and log into the clusters respectively. It's pretty much a login. So currently I'm here in my demo cluster. So, and then that is okay. Let me start that to Kubernetes. What it will do is it will build the source code. It will build the Docker image and will then deploy that into Kubernetes. Oh, okay. It is already starting here my pods. That was faster than I expected. So what I need to wait now is for the load balancer to become ready. So what Kubernetes does is I can create inside the cluster a load balancer, and it will talk to the cloud API to provision a virtual load balancer and to get my also my IP address. So, and let me access that. So, and with that, this is my new guest book. Do I have here a chat or something like that? that I can share with you. Well, probably not. I can put in here my name. Hello, DevFest. So I post it here, and what will happen is Kubernetes has deployed for me a MongoDB, and these messages will be stored into MongoDB. So that means my my guestbook can store a lot of messages. I can scale out depending on the load. Kubernetes can create more replicas, and it can also scale it down again. So that means depending on the load, Kubernetes is scaling down and scaling up the replicas that I need here. Yeah, that is a deployment. What I can also do is I can debug directly on Kubernetes. I don't even need to run my my workload here on my local machine. I can use the cloud right away to deploy my workload and debug. So let me try to do that. Therefore, I need an entry point. They must have a handler. Yeah, that looks good. Listen, handle. Let me set here a breakpoint. Since I've stopped it, all the workload is gone here. So what I do now is I will start it in the debug mode, and hopefully it will create the new pods. And when I create a request, it should trigger my breakpoint. So let us wait for that. So everything is running now. I still have to wait for the load balancer. Oh, okay. That is still pending. Okay, there we go. So I have, since the old load balancer was gone, it was really entirely deleted. I get a new IP address, and if I hit that, hopefully my IDE will tell me, okay, there is a request for that. Probably not, because maybe there's something in the cache. Okay, that was probably at the wrong place. Okay, then I need to set my breakpoint somewhere else. No, that is the error. Okay. Yeah, sorry. That is for that I would need to understand which where the application lives. So therefore I skip that. Or what I could do is I do that on a more simpler application where I understand it a little bit more. So that is for the development. So as I said, you can really deploy that on the cluster in a more simpler. Or maybe I should. Oh, that is okay. Yeah, sorry. That is always the beauty with the demos. I would also like to show you something else. I stop here everything, and this will go away. What I would like to show you is how easy it is to deploy applications into Kubernetes. Therefore, I will take something from Bitnami. As I said, I can add here repositories to my Helm, and I can pick here WordPress. So this is how I install WordPress on my Kubernetes cluster. I simply say Helm install. I give it a name because I can install multiple instances of WordPress. And this one I call DevFest WordPress. So, and then I deploy it. And what you will see here is that it again start everything for me that I need. Here it starts a MariaDB, and it starts the web server, and it creates services. Services is something like an DNS entry inside Kubernetes and also a gateway to the outside world. It is a networking object. Actually, it is software. It is a software-defined network, and there is a crash loop. So I can, out of curiosity, actually, sometimes it sometimes it needs a little bit time to spin up. What you can also do is, what I'm doing now is I look into the logs. Okay, get logs F. So let's have a look at okay, then let me describe that. Okay, I've tried that 50 minutes before this this talk, and there it was working. So then let me delete that again and let me try it again simply. So maybe that helps. So what I'm doing now is I tell the package manager to delete that. Then let it start again. If you like, in the meantime, we can also answer some questions in between now, if you like.
Yeah, well, just to explain a little bit to the audience. So Kubernetes has a lot of similarity in like a concept to RAIDs, or the hard disk RAIDs, right? When they were first introduced, because there was so much data you had to store, you couldn't just use reliable hard drives, you had to use unreliable as well, and have to do with that somehow. And now we are facing like similar challenges by not having enough of processing power. That is that is like a good bare metal processing power, and we have to rely on let's call it, less reliable processing power, and therefore we have to deal with the challenges of using it, keeping it running, even if something fails, keep it moving from one thing to one hardware to another hardware, and to keep it balanced, because usage is also spikes every now and then. But it all comes from the problem that we are not having enough processing power for our peak usages, right?
Exactly.
So just want to know your opinion. What is about to fail us next?
So first of all, let me say a little bit to RAID. Yes, Kubernetes is adding redundancy. It is you can really add here say that Kubernetes is a RAID for compute. Because what we need is we need to react on peaks. For example, during the Corona times now, everything has become very unforeseeable. The airlines, unfortunately they now need less compute power. Online stores, they need more compute power. Conferencing systems like here StreamYard, etc. They are booming, and with Kubernetes you can react on that. You can simply plug in new hardware, and it will be consumed directly from the cluster. So what's next? I think Kubernetes has already become boring in a positive way. That means it is very reliable. It is there already since 6 years. I'm operating that at a British telecommunication company, which is very well known, and at a Swedish furniture company, and they rely their workload on that. So what's next? Next will be building on top of Kubernetes. I have mentioned, for example, Knative in the beginning. So Kubernetes is a very low level, and next we will see more things evolving on top of Kubernetes, like Knative, where you have a serverless platform that has become a standard. With Istio, you have service meshes, and I think the ecosystem that I've presented, that will more and more evolve. There will becoming more software that can be run on Kubernetes.
Thank you. So Sarik wants to know how to control the security. How is it implemented in K8?
Kubernetes itself is not very secure because it focuses much on deploying your workload and running that workload. That doesn't mean you cannot operate a Kubernetes cluster in a secure way. That just means you have to take care of it. Kubernetes has the concept of network policies, which is which is actually IP tables on the nodes, where you define, okay, this pod can speak to another pod. That is one security concept. It has pod security policies, which makes sure that you run only secure software, but you have to configure that. That means by default, Kubernetes is pretty open. Therefore, it is advisable that you use a managed platform like the GKE, where you have a network where the nodes are in an isolated network, and which is already quite hardened. And on top of that, what I usually do for production workloads, I use Istio. Istio is adding another security layer on top of Kubernetes, where the pods are talking to each other with mutual TLS. That means each pod has to present a service certificate, and the calling microservice has to present a client certificate. And with all that, you can operate your workload in a very secure way. However, as today, you need to have some knowledge. That is not because Kubernetes is complicated. It is because your use case is usually very complicated. Therefore, that to operate something in Kubernetes requires quite some knowledge. Getting started with Kubernetes is easy, but then you need to understand all the concept of network policies, pod security policies, OPA rules, for example, which is also another framework to make sure that the pods are not violating that. I'm also operating quite some large clusters for the mentioned telecommunication company. We have there more than 10 countries operating this, their stuff in the same cluster. There are also subcontractors working on the same cluster. So that means you have a lot of people who have access to that cluster, and you need to apply security there thoroughly. You can operate it securely, but you need to know how.
Okay, thank you. And also, there are several cases where I have seen, at least myself, companies that are not using Kubernetes in their production environment. And I would separate them into two groups, like those who are afraid of it and those who are underestimating it, because they yeah, we know we have hypervisors and everything else. It's kind of running, so why should we? So let's talk about the first, those who are afraid. Mostly that's because they either haven't tried it or haven't felt the actual benefit, and they don't know when to start implementing Kubernetes into their process. What would you suggest? Like, if I'm developing a new application, like not using some that's already made, but if I'm developing something new, when should I start using?
So I can confirm these cases, and I've actually onboarded a lot of companies to Kubernetes, and my recommendation is always it is important to onboard the people who are supposed to work with that. The most important thing is to understand Docker. And my recommendation is to get your fingers dirty, right? You need to provide people with the right tools. It is, for example, what I've seen often in enterprises. They are providing the people with Windows laptops, and where these are as locked down that they cannot even start a Docker container on it. And that makes development very difficult for the developers. And I've seen a lot of friction because the developers are not provided with developer laptops. So my recommendation here is to provide at least virtual machines with Linux, so that the developers can get their fingers dirty, that they can start writing their code and putting that into a Docker container and then starting that into Kubernetes. And then you have a learning curve, which is quite okay for the people. They need access to Kubernetes. Often I've seen that companies are saying, okay, we have ones are the developers and the other ones are the operators, and the developers should develop and the operators should take the code and ship that into Kubernetes. that is not working so well, because you always have a very high latency between that, because developers have no notion about what happens inside the cluster. They don't know how to work with memory, etc. They don't know how to take care of startup times, etc. Therefore, DevOps here is the key to success, to have everybody together and to grant everybody access to Kubernetes, at least to a development cluster. It is okay to have a prod cluster where you have a limited number of people who have access, but the developers must have access to Kubernetes. Otherwise, you will lose a lot of time.
Well, since you mentioned developer laptop, and we've heard that Apple laptops and computers are shifting to IRM in the near future, like there are implementation of Kubernetes that run on IRM platform, including Raspberry Pi. But do you think we are going to face some problems anyway with adapting to new hardware environment, to new architecture?
What do you mean of hardware environment? Hardware environments for Kubernetes or for the developer laptop?
For the developers that are going to use Apple computers with IRM, that is like way too fresh, I would say, since it's low level.
I don't think so, to be honest. First of all, if you work on a Linux machine, you can start your Docker containers natively. On Mac and on Windows, you do that in a virtual machine, and I'm pretty sure the vendors Microsoft and Apple will take care that you can start it. Apart from that, to interact with Kubernetes, you need the shell. As you've seen, I was using the shell, and the command line tool here is very lightweight. It is written in Go. It can be compiled to literally anything. It is actually, in essence, it is just an HTTP client which talks to the Kubernetes API over the network. So that means you don't have any real hardware requirements to the developer laptops. You more have a software requirement where you need to have access from your machine to the Kubernetes cluster. Because the problems that I have described was more on the network level, where the networks are so tightened, and also it was often asked, why should the developer have access to Kubernetes? They should write their Java code, and that should be then operated by someone else. That is more, I think that the friction here is more on the mentality, not necessarily in the hardware.
Thank you. And questions from Jamshid. So do you have suggestions on where to start? Because, you know, back in the days, there was a problem that it's hard to find the source because there are so few. And now it's probably hard to find the source because there are so many and you don't know who to trust. So what's your opinion?
I know there are a lot of books out from Pact Publishing. I think it's Mastering Kubernetes, etc. That is one book. Personally, I must admit, I have never read a book about Kubernetes, to be honest, because I started with Kubernetes when it was in version 0.6, and there were no books back then out there. A good starting point is Kubernetes.io. There you get a lot of resources, very good explanations. There, everything is very well documented there. And also, if you simply go to the GCP console and start a GKE instance, there's also already a lot of explanations. So the easiest way to get started is simply go to the Kubernetes engine and follow the steps there. and also on Kubernetes.io. Also, a lot of YouTube videos are around that. I think Kubernetes is widely adopted. Apart from that, I'm sorry that I cannot recommend you a particular book, because personally I've never read one about Kubernetes.
Yeah, right. It all usually comes down to practice first, right?
Yeah.
Because the more you practice, the more you understand, and the understanding is not similar to knowledge. And could you share your insights on anti-patterns of implementing Kubernetes? Because, well, for instance, I've seen situations that, well, it's not the anti-pattern of Kubernetes implementation itself, but more about management, I would say. But I've seen where, like, DevOps team is going at first into new project, and they are implementing the infrastructure and creating all the pods logic of their connection between each other, even before software architectures jump in. So they kind of run the show, and then the software developers have to follow them, which sometimes leads to some problems. But I'm sure that you have to seen more interesting cases on how not to implement the orchestration.
Yeah. First of all, it is not only about the orchestration, right? The biggest problems that you usually have is with the people understanding that new concepts. An anti-pattern is more related to microservice. To build two big microservices or to build two small microservices. The first case is the more common case, that you try to build a microservice that does everything. If you want to be successful on Kubernetes, you should write your microservices in a way where Kubernetes can scale them. Right? You need tiny entities that can be spread over the cluster. If you build a big monolith, I'm not saying that monoliths are entirely bad, but they are not very good at scaling in Kubernetes. You should build your microservice with one thing in mind. A microservice should one thing and do that thing right. For example, I'm currently working on a project where you can create PDFs, etc. There is one microservice which takes fully care of creating a PDF. It exposes an API where you put in some data and where you get back that PDF, and it does nothing else, right? It doesn't take care of authentication, doesn't take care of logging, etc. You should write the microservices in a way where you really tailor them. First, a microservice should be not bigger than the team can maintain. One team should be able to maintain one microservice, and teams. By speaking of team size, I mean one pizza team. So that means a team should be bigger than a big pizza can feed. I've seen Scrum teams with more than 20 people. That is not working, right? You should have smaller Scrum teams, and the size of the microservices is very highly related to the number of people who are working on that. And that is one anti-pattern that I've seen. Too big microservices. There's too much functionality in that. Use an API. Use a REST API, a gRPC API, and let the microservice be specialized on what they're doing. And continuous integration is a very, very important part. Another anti-pattern is that people are working for weeks and months on their microservice, and then they start deploying that into the Kubernetes cluster. They develop their huge software, and then they try to deploy that. You should start creating a stub of the microservice, deploy that, evolve that, and then have it continuous deploy. And a continuous testing is also very important.
Okay, thank you very much. And if there are no other questions, do you want to finish the check on the demo environment, or what do you think?
I could use something else. I'm currently astonished that this is not working, because it was working a few minutes before the demo. I must have messed it up somehow.
Don't worry about it.
I'm not worried.
I mean, the whole concept should be quite understandable to the audience, that currently new interactive development environments, they support a lot of these infrastructural applications, and most of them are created by a few clicks. But I would also recommend the audience to understand the things that those clicks do, just in case you have to debug it, because you're going to have to debug it.
Yeah.
Thank you very much for your time.
My pleasure. Thank you for having me.
Thanks, and have a good day.
Likewise. Have fun at the DevFest.
Okay, now it's all about the Kubernetes for beginners. I hope you use this technology, especially since nowadays production environment require a lot of processing power at a certain points, like creating a peaks, and it's hard to be sure when that happens. Our next speakers, Rashid and Nur Islam, are going to talk about a practical implementation of artificial intelligence and machine learning to control a working environment.
Hi, I'm Rashid.
I'm Nur Islam.
Hello. Nice to have you here, guys. So the stream is yours.
Okay, can you see our? Oh, great. Okay, so let us discuss how we created an application. We call it TimeClock. It's a practical application of the computer vision technologies for employees' time tracking. So we wanted to discuss what thing we managed to do, what problems did we face, and what other concerns do we have yet for now. So what was the goal of the whole project? First of all, it was the accurate time tracking. So we want to be sure that everyone comes on time. The second thing was to avoid body punching. The thing with the classical RFID card is that you can just give it to your friend, and he or she will just use it for checking in and make HR think that he came on time. Right now, we use this project for our own company. We use it to control geographically dispersed locations in different cities, when it is much easier to get the report than to see what is happening there. And lastly, but not least, we automate time reports. Basically, our target auditory for this project is companies that have non-qualified employees, such as, say, sales associates, waiters, and bank clerks, whose job is not tolerant for being late. From our point of view, from our experience, it's not the best solution for entrance control system, as long as it has not 100% accuracy and it takes some time for recognition. And of course, we need to mention that even for our current case, it controls only checks in and checks out without controls of authorized leave. So there's always a chance that employee comes on time and then they just leave an office without notifying anyone. And of course, we cannot control it. So, Ruslan, please.
Okay, what about work principles? And firstly, we have 6 steps how our application works. The first step is phase detection. As a tool for phase detection, we considered two libraries. The first one is OpenCV, and second one is Google ML Kit. And we settled on the choice number 2 because of this. It's firstly low entry threshold, and second one is because it's much simpler than OpenCV, because when OpenCV we need to learn it, how it does work, and then other things. And I want to consider that before face detection, we hadn't got a face detection, and that's why it's caused many problems. This problem is like when first problem is photographing without a face in the photo, or several faces on the photo, and it could lead to cheating or misunderstanding of HR, and sometimes the employer could even press the photo button accidentally. And this situation, if the face detection doesn't detect anyone, it detects only one face, it shows the press photo button, and after that, employees could press this button. And second problem is more technical. For example, most part of the photo, it's just background, and the valuable part of photo is a face, and this face approximately 50%, just only 50%, and other part of the photo is just background, how I said before, and that's why we cut only desired part of the photo with face detection and compress it, and the result in the final picture. The face weighs about 100 or 115 kilobytes. Also, the face detection helps to force an employee to come to required distance to the camera in order to take high quality photo. It was related with face detection. And let's look about live detection. Okay, about live detection. Surely, one camera on the budgetary tablet is not enough for making high quality live detection, and that's why we try to use some tricks for this. In Google ML Kit libraries have one interesting class as Firebase Vision Face, and we read these indicators from Firebase Vision Face every millisecond or several times per millisecond, and consider the time between the changes these values, and try to understand is this photo a real person on the camera, or is just static photo. And of course, it's don't work. For example, on bank, we don't consider our application as a for bank security system, and that's why it's most of cases it's enough. Okay, what about face matching? Face matching. In the beginning, we considered a long time search appropriate tool for this, and we considered OpenCV, and we settled on the Azure Cognitive Service. Why Azure Cognitive Service? Yes, because firstly, how I said before, it's more simpler, good, well documented, and user-friendly, programmer-friendly API for this. And all needed is just get photo from face detection, compress it, and send to Azure Cognitive Service. After that, Azure Cognitive Service responds us with in percentage, with probability, with percentage the employer similarity or not. If the is, for example, percentage is higher than 60%, we think it's a real employer, and we confirm this photo. About audit. About confirmation. Okay, confirmation after how the application got a response from Azure, and if the current response recognized him, the application is asking the employees in confirmation of the correctness. And at this moment, if the employees asks OK, we save this photo in local storage. Because why we save it on local storage? Because Azure couldn't work without internet connection. Yes, it's always because its service was located on the cloud, and we saved in local storage. And when internet connection is appear, we send this photo to the cloud, to the Azure system. Yes, and after that, how the employee confirm himself, HR after that could recheck it, recheck his answer, and everything is doing on the admin panel. I talk about later. Okay, about audit. Regarding audit regarding HR registers an employee via application, and it has special password for doing this, and just employee couldn't do this. After that, moreover, HR also have admin panel, how I said before, and in this admin panel provide all information about all employers, and also all employees confirmation. And he also HR also could, for example, download different reports. Also could could also show diverse charts of different indicators. It's watch related to audit, reinforcement learning. About reinforcement learning. Firstly, we have a problem. First time when we developed this application, we have a problem with the face recognition, because when an employer registers himself with a glass, for example, and after that, the system couldn't recognize him without glass. And in this situation, Azure help us with the API. He provides special API for reinforcement learning, and after how the employers take a photo, we send his photo the Azure again and again, became more smarter than he was before. And that's why, and with this way, we resolve this problem with reinforcement learning. Okay, it's your turn.
Okay. Let me continue, please. Our next thing we want to discuss is about things to consider. Sorry, I have a comment here. I will try to enlarge it. Not sure if I can do full screen correctly. Hope it will be better. Okay, so what we understood from the project. So first thing is about like an use case when this project is suitable. So as long as we have limitations, it's not for our point of view, it's not kind of the best way to use as a part of security system, but it's good enough to be used as a time tracking system for certain conditions, like for tracking sales associates, waiters, and other people like this. Another important part is about lighter condition. So as long as we try to use budget devices in order to make it affordable enough, they need that the photo should be lighted enough, and it's like about place where this tablet could be placed. Third thing is about hardware. So we wanted to like stay within $200 threshold for devices, and for instance, we have like this kind of device from Samsung. I'm sure that there are other devices from other vendors in this particular price category. We noticed that it requires new Android version from 5 or higher, and speaking about the hardware requirements. So for our perspective, from our experience, you should need like a tablet with at least 2 GB of RAM and 2 cores. We tested using less powerful tablets, and it worked really bad. So, but as long as price is not very high now, I think it is more than possible to find a suitable device within $200 price tag. And the fourth one is about internet connection. So basically, it works best when you have stable internet, which is not always the case. So we develop special offline mode when employee checks in and system understands that there is no internet connection. And so system asks employees to manually enter their name. As long as system stores the photo, afterwards, after the internet connection is available, system performs audit by itself. And if there are any doubts, I mean, like the probability is too low, this photo is sent to HRs, so can they manually review the photo. So let's talk about the cons and problems that we met during the implementation. So first, it takes time. So it takes 2 to 3 seconds to process compared to like 20 milliseconds for RFID cards. So again, like if you have a big enough company, please consider putting several templates. Second concern is about recognition rate, which is definitely below 100%. So there should always be a kind of backup plan. Third, at our day, at our state-of-art technology, doesn't work for kids. So it works only for adults. So it is suitable for such use cases like employee tracking, but it might be not the best solution for tracking students. Fourth, it depends on life conditions, definitely. And last but not least is privacy concern. So we had a case when one of our employees just didn't agree to register in the system. He said that, like, I don't want to share my photo. It was okay for us because we do not use this project as a major tool because of our nature of business, so it's not like a big deal. But in other cases, for other type of businesses, like say, again, grocery stores or restaurants, it might be a case. So this moment should be written in their contracts, I don't know, and just to be sure. And of course, we do not collect photos. We just store it for audit purposes and other stuff like that. And this should be told by employee that the photos wouldn't be published anyway. And finally, I wanted to talk about what we are thinking about the development from our point of view, and we'll be happy to get any comments on such topics and other comments and advices how to develop our system. So first, we are considering about onboard recognition. So our major slowdown comes from the fact that we use cloud solution for recognition. It works really nice. It has high recognition rates. It has low error rates, but it's in the cloud and it takes time. So with the onboard recognition, we could achieve our second goal is to increase recognition speed. And one other thing, which is especially important for in our days, is about touchless UI. So we're considering adding other kits, other ML kit functions to be able to allow employees to confirm by gestures and make choices by voice. Okay, this is for now for our presentation, and we have several questions. So let us begin with them.
Okay. Yep. Thank you very much. So yeah, we kind of like we as people, we as engineers, we're developing artificial intelligence in order to do our jobs, right? and now we are using it in order to control us doing our jobs.
Yeah.
Now, Jamshid John asks a few questions, like why do you decide to use Google ML?
Well, as Nursalam said, we considered two choices, OpenCV and Google ML, and
okay, why we decided to use Google ML? It's a simple question a simple answer because Google ML is most simpler than other type of these libraries. For example, OpenCV is more harder, and we need to, for example, learn OpenCV, how recognize, how face detect. It's demand a lot of time. It's demand more time than we just download Google ML library and just run it, and it works well. It's everything which you need. It just download from repository. It's enough, and that's why we decided to use Google ML. I think it's
and what are the requirements for cameras that you've been
requirement?
Yes. So let me answer this question.
Okay.
So we use 2 megapixel webcam, and this is the device. I can show it. It's Samsung and tablet. So, okay, I don't know if it's easy to see the number. It's SMT295.
Budgetary tablet.
It's a budgetary tablet. Yes, we just like bought. We were looking for the most budget solution that would work. So it's Samsung Galaxy Tab A, which is below $200, below $200 price tag, and its model is SM-T295.
And how much data you need in order to start recognizing people like good enough, and how many people are we talking about? How many people are we talking about?
I said before, this service is for face recognition. We use Azure service, and the Azure service already is learned, and everything is needed. It's just one photo. And you send one photo to this cloud, and after that, cloud already could recognize you. But to increase the recognized quality, you can send a lot more photos than one. For example, if you send 5 photos, it will be good, and it will recognize you with 100% accuracy. But one photo is enough because we use already working service, already learned service. So,
and how does recognition happens when the tablet is offline?
Well, it just doesn't happen, actually. It's a short question, etc. So basically what happens, we store the photo. So like someone comes to office and makes a photo saying like I'm checked in, and tablet understands that there is no internet connection. So tablet asks this person to enter his or her name manually. And it just stores the event as not confirmed. At the moment the internet connection is stable, the system sends the photo to Azure, and Azure gives the probability if this person is that one is who is he's saying he is, and that is how it works.
To cut long story short, we just if your internet connection doesn't exist, it's not allowed. We just save the employer's photo on the local storage, and after that, how internet connection appear, we just send this photo
to the cloud.
To the cloud, yes, and after that we get response, and after that, HR could consider consider this result and compare photo and employer.
And use case allows it, right? Because you don't need to provide instant access to the person by face recognition. You just need it like weeks after it happens, just to combine statistics and understand the working hours for the person.
Yeah, exactly.
And also, why wouldn't you use like ordinary IP cameras and a computer with GPU as well?
With ordinary cameras, IP cameras, it's just our design. We wanted to make it kind of user-friendly, and the good thing with the tablet is that they do not only have the camera, but also they have a screen. So a person can see themselves, can confirm the choice, and so on and so forth. So it's kind of a little bit easier. Also, the thing is that with the tablet, we can get a good photo of the person when person looks at the camera. Like if it could be just an ordinary IP camera, there is a risk that person would just like turn around or, I don't know, wear a mask, as it happens in our days. So that's why we decided to use tablet to make a very specific photo with the face. With TPU, it's also an interesting question. So basically, we thought it would be what we're doing right now. It's MVP, and meanwhile, Azure gives us very, very good service with a very low price tag. I think we use it almost a year and we didn't pay anything. So we do not want to invest money not in GPU, nor in development of the software, or even adapting the existing software. So it's just like cheaper and faster to use cloud solution.
So there might be a little bit misconception with these questions. As far as I understand, this is not your startup. It's more like a side project to provide more convenience to the office, right?
Well,
or is it?
It's kind of startup, I would say. So basically, if you talk about our situation, we are a very well-known company in a retail market with our project Webcasa, and so we decided to add like extra products for our existing customers, and so we started doing it like for our own, just to see if it works, and if it works nice, we have a existing client base that might buy it. So I think it's startup. It comes
like an addition to existing project.
Yeah, for us it's kind of an upsell. So we have a good relations with a lot of retail industry, with HoReCa industry, but why not just sell them more? So
okay, so the concerns about privacy and about the laws as well. I mean, here in Kazakhstan, we have a certain regulations that don't allow us to use biometric data without expressive agreement from the biometric data owner, being a person, like anywhere on the street, which is why you had to use the contracts. And now you're saying that the images are being sent to the cloud, which means they are also transferred into the probably other countries' like legal area, so to speak. And in Europe we have GDPR in progress that is specifically describes how to use and how not to use personal data. Did you face anything about that?
Yep. So first, so there are certain limitations about privacy and concerns about the privacy. So we cannot just share people's faces and even people's photos in the internet, even if we have it. So we have two things. First is our use case. It's not like for tracking clients. It's for tracking only employees, which have a kind of contract with the employer. And that's why this thing about expressive agreement to use biometric data for time management can be written in the contract. It's not a big deal because we just don't do it with the clients. And second, yes, we have faced the problem when one of our employees said that he is not going to make the photo himself. As long as it was not a big deal for us, we are a software development company, so we don't really care, in fact, if someone is a little bit late. But so we just agreed, it's okay, if you don't want, you don't have to. But of course, in some cases, some people might disagree to use it. And it depends on the nature of business, what will they do. From our point of view, like saying our number of employees, we have 200 employees, only one denied, and we're not like, I mean, like our employees a little bit different from restaurant, from waiters or sales associates. They know much more about what, how face is important, face image is important. And even in this condition, you have only 1.5% rejection rate. So we think in our particular use case, in our country, in Kazakhstan, it's not a big deal. It might be, of course, it might be a problem in Europe, but right now we're not targeting Europe market.
But again, if our solution will be a success, we can just replace some technologies and store this information in our servers. It's not a problem, I think. So.
Which is also why you mentioned that you could not use it for kids and students, right? Not only because there are different algorithms for kids' facial features, but also because kids' biometrics data is like a really big concern from a legal point of view.
Yeah, exactly.
Yep. Well, if there are no other questions, then thank you very much. Thank you very much. It's always interesting to see how things like face recognition are being implemented in a certain use cases, because there was a lot of hype around face recognition, but not too much of implementation apart from, well-known implementation apart from maybe China, who is face recognizing like everyone and everywhere, if they can. And good luck to you. Thank you for your participation and have a good day.
Thank you.
Thank you too.
Have a great day.
Bye-bye.
Bye.
So this was a short presentation on practical implementation. Now we are going to switch to our next guest in just a few minutes, who will talk about semantic search using the vector search engine, which is also quite interesting topic, because with so many data that floating around us, the task of finding something you want to find is well, a big one. So please stay with us for a little while, and we will start in a few minutes. Okay, guys, I'm sorry for keeping you waiting. It seems like our next speaker is experiencing some kind of technical problems with connecting, so we are still waiting for him. And while we do, I thought that we might talk a little bit about GDG chapters in Kazakhstan and our plans for the next months or maybe bigger, depending on how soon all the COVID situations will resolve. Since we are unable to create live meetings, we will be keeping it like this online. So we are open for suggestions for the topics that you might want to discuss. Do you want some like more topic specific meetings? Do you want streams that look more like an interview? Would you like to hear some specific speakers like up front so we can ask them to join us? For all of that, you're welcome to send us any suggestions, send us questions, whatever you would like to see and hear from us. Now, development community here in Kazakhstan is quite big. We have like quite big data science and machine learning community. We have a lot of developers in both mobile and web development, and also there are a lot of other developers in Central Asia. For the nearest future, we will be combining our countries of Central Asia into, generally speaking, one line of events. So whatever you want to talk about, like AI, Internet of Things, game development, web development, mobile development, hardware development, anything, we can talk about it, because there are a lot of speakers who could share their experience. There are a lot of maybe you might wish to hear something about startups, how they work, how they promote themselves from the business side of things. We are sticking into the not promoting platform kind of concept. So we don't want you to use us as a promotion platform. But if you want to share your experience, and if you want to listen to someone's experience on how they promoted their startups, how they were looking for their early adopters, how did they measure all the business metrics that are required for the operation and so on, please ask, and we will be into that. And I'm open for any questions. If you might want to ask something, just type it in. Short update to the stream. We are sorry to say that our speaker about semantic search wouldn't be joining us, which is sad because it seems like he got too sick, too ill to be part of the stream. We wish him health, and we hope he gets better soon. So I would still suggest you to sorry about that. I would still suggest you to look into the topic. Semantic search is an interesting kind of a task in order to understand the whole work with unstructured data, mostly text data. There is a lot of unstructured data. You will be facing it on a daily basis, and working with it is not simple. Anyway, we are open for questions until our next slot is open, which will happen in 40 minutes or less. Thanks for staying with us.
Can you hear me?
Yes, yes. Nice to have you here.
Awesome. It's good to be here. So I will share my screen. Okay. Okay, you should be able to see what I'm sharing now.
So welcome back, everyone, and thank you for staying with us. I'm sorry again for keeping you without speaker for the last hour, because sadly our previous speaker got very ill, and he sends his regard, and we are wishing him to get better soon. Now, our next presenter is Mr. Robert John, who is a Google developer expert who can tell you a lot about data engineering, just to begin with. Now, Google Cloud Platform, as you've already heard from our previous presenters, allows you to both create and inference TensorFlow models without thinking about actually sustaining the hardware. Now, I'm giving you a scene, please.
Hello, everyone. It's good to be here. So like you've heard, my name is Robert, and my Twitter handle is, as you can see on the screen, at Robert_THAS. So this presentation will be about TensorFlow on Google Cloud Platform. So as you probably already know, TensorFlow is a numerical computation library. It's one of the popular libraries that is used for training machine learning models. Now, you're able to use TensorFlow everywhere. So typically when you get started, you'll be on your computer, you'll get TensorFlow binaries, you install them on your computer, and you start with training. Now, what happens is you typically need to worry about the size and scale of your hardware, because different problems might require different types of computation. The hardware, how much storage do you need? How much processor do you need? Do you need a GPU or not? And typically, if you're working with your own hardware, then you have to worry about going out to purchase those and how to set them up as well. Now, of late, we've also had Jupyter Notebooks. Jupyter Notebooks have made machine learning pretty easy. And there's also been something called Colab, which is hosted by Google. And Colab will let you open up a browser and just start working with TensorFlow. You're able to install some things that you need, but Colab essentially gives you a virtual machine in the cloud, but you don't control it. You don't control how much storage you have or how much processing power you have. So that's where TensorFlow on GCP comes in. And this is actually called TensorFlow Enterprise. So on GCP, there are lots and lots of resources. And they range from high levels of automation to low levels of automation. You have things like Cloud AutoML. Cloud AutoML will give you the ability to train your own models, but without writing your own machine learning code. And you also have pre-trained APIs, and these are very popular. Lots of people, lots of even large companies make use of these pre-trained APIs. Now, on the other extreme is where you need to write your own code yourself. And that's where TensorFlow Enterprise comes in. And what it is it's essentially virtual machines on the Google Cloud platform that are configured for you, where they also come with guarantees from Google that they will be there for a long period of time, guarantees that the code base will not change for an extended period of time. So think of it like enterprise grade Linux versus Linux that you use on your laptops. Now, with TensorFlow on GCP, you're able to do your training, as I mentioned earlier. So you're able to go train your model, you're able to evaluate the models, and you're also able to deploy the models to production. So when you work, especially for a company, it's not enough to just say, oh, we've trained the models. There's also the question of how do we push these models to production? There are also other questions such as where do we store our training data? A lot of the time, the training data could be large. So how do you store the training data? You need to store it somewhere that has fast access. How do you access the data that you've stored as well? Maybe just a second. Okay, so there's also the question of how do you access the data that you've stored, and then from that data access, how do you train the models? How do you deploy the models? So we're going to be looking at all of those in this presentation. So in a nutshell, TensorFlow is a numerical computation library. It's similar to other libraries that you have out there. NumPy is one very popular numerical computation library. There's also PyTorch. A lot of the time people ask, what is the difference between NumPy and TensorFlow? And one very strong difference is the fact that TensorFlow will let you make use of application-specific integrated circuits. One example of that is a GPU, but another example is something called a TPU that was developed by Google. Currently, TensorFlow is in version 2.x, so you have things like 2.1 and 2.3 are specifically available on the TensorFlow Enterprise. Other versions are available outside of Enterprise. You can read up on TensorFlow and access tutorials on this link here, tensorflow.org/tutorials. It also has a large community, so you'll find lots of blog posts and articles out there, videos that people are sharing about what they're doing. TensorFlow is usable from various programming languages, although for the purpose of this presentation, we're going to focus on Python. But it's available via JavaScript. It's available on the browser and via Node.js using JavaScript. It's available for mobile devices using TensorFlow Lite. It's available for edge devices using TensorFlow Lite Micro. And then it's available via APIs through something called TensorFlow 7. There's also something called Swift for TensorFlow, and recently TensorFlow was released in Java. So there's a wide ecosystem out there for TensorFlow. So let's go on and look at TensorFlow Enterprise. So the first thing that you get from TensorFlow Enterprise is cloud scale performance. Now, what that means is you're able to scale your machine learning workflows on the cloud with optimized performance. Depending on what you're doing, you're able to launch training in the cloud, not inside of one particular virtual machine, but you can actually ask the Google Cloud to launch a compute cluster for you. And so what this means is, as your load increases, as the amount of work that you need to do increases, more virtual machines will be launched to handle your job. The second thing that you get is managed services. So similar to what I said with the compute cluster and launching of additional compute resources, that's handled by managed services. So managed services will just ensure that you focus on your code. You're not having to write any, let's say, infrastructure as code or any sort of resources to handle launching and scaling virtual machines or memory or storage. None of that has to be your concern. All of those are handled by managed services. And finally, you also get enterprise-grade support with TensorFlow Enterprise. And so what that means is you get long-term version support on GCP. You'll get patches, you'll get bug fixes, and you'll also get backports. Now, enterprise-grade support is really important because just think about how companies operate. Companies don't operate in trial mode. A lot of the time, when you write something in a company, it could run for the next few years. Now, that's completely different from how code bases like TensorFlow are maintained. So with TensorFlow, you could have a new sub-version or sub-release every few months. Now, that's not something that you want to have to deal with. You don't want to have to go back and patch code that is working, that doesn't have anything wrong with it. So with enterprise-grade support, you're sure that if you write your code in, for example, TensorFlow 2.1, even when TensorFlow 2.7 or 2.8 is released, your TensorFlow 2.1 will continue to work. The code that you've written for 2.1 will continue to work. No problems there. So with cloud scale performance, you have access to Google Cloud Storage as well as BigQuery Reader. So the reasoning behind this is that if you're dealing with images, a lot of the time, you want to have those images somewhere where they can be accessed via a very scalable mechanism. So think of it this way. When you train on the cloud, you're going to have multiple computers that are training on your code, but on subsets of your data. And then at the end of the day, the results will be merged. The only way that this will work is if you either have a copy of the training data on every single virtual machine, or you have your data somewhere that allows for fast access. And just think of something that is similar to network attached storage. And that's how the Google Cloud Storage works. So Google Cloud Storage will give you a storage bucket with fast access. If you're dealing with text data, a lot of the time, this sort of data could be stored in either in text files, and Google Cloud Storage will handle that, or in BigQuery. So BigQuery is Google's petabyte scale analytics database. And it's easy to store text in tables. It's also easy to store numbers in tables. So having access to Google Cloud Storage and BigQuery via TensorFlow Enterprise is huge for the kind of cloud scale performance that enterprise clients are interested in. So I will skip to slide 13. Okay, so if you work with TensorFlow Enterprise, you're guaranteed of at least 3 years of support. So what that means is if you start using TensorFlow Enterprise version 2.1, it's going to be supported all the way onto the year 2023. So that gives you 3 years of stability before you need to migrate your code to a new code base. The beauty of that, of course, is that typically you're going to be retraining your models. So somewhere along the line, what you need to do is plan for a new model version to make use of another TensorFlow Enterprise version. But for now, you can be sure of 3 years of support. So let's look at actually getting work done with TensorFlow on GCP. So there are two things to bear in mind when you work with TensorFlow on GCP. You're going to be dealing with either notebooks, which is similar to what you get with Colab, or you're going to be dealing with deep learning virtual machines. So these are virtual machines, but they're specifically configured for deep learning tasks. So the main pain points that are addressed by these resources are the fact that installing frameworks can get complicated. So typically, if you get your own hardware, or even if you're working with a virtual machine, you have to worry about the operating system, you have to worry about device drivers, you have to worry about compatibility. And compatibility can get pretty complicated quite easily. Sometimes you find that certain versions of certain drivers don't work well with certain versions of certain operating systems, but also those versions of the operating systems are the only ones that work with the hardware that you have. So installing frameworks can get pretty difficult. The second thing is that in machine learning and data science in general, there's always something called reproducibility, which is if I run an experiment, how do I get you to run the same experiment in exactly the same way so that you get the same results? Typically, if you're working with Jupyter notebooks, then you have things like setting your random state so that once someone else is running the notebook, they're able to get the same results. But in this case, you're working on a larger scale. So how do you ensure that reproducibility is available to everyone? So the solution to these problems is the deep learning virtual machine images. And typically you'll get, as your operating system, you'll get Debian. And it's optimized to run on the kind of hardware that Google Compute Engine provides to you. Now, these deep learning virtual machines come with a bunch of libraries that are pre-installed. You can choose your own combination of things like processors, whether or not you want GPUs, the particular types of GPUs that you want, how much RAM you want. You can choose all of those. And those choices will affect the cost of running the virtual machine over a period of time. So if you can see the lower part of the screen, what you see is various configuration options and the cost that they contribute to running that virtual machine over the period of a month. Now, you can always launch deep learning virtual machines via the Google Cloud Console. So if you're on GCP, you can always launch those, or you can always use the command line tool and type in something similar to this. So you're actually creating a compute instance. So the command gcloud compute instances creates a virtual machine instance for you that you're able to work with. The difference here is you're able to specify an image family. So the image family here, which is TF2 Enterprise Latest GPU, comes with a pre-packaged set of operating system plus libraries plus GPU plus the GPU drivers and things like that. You can specify your image project, which is a deep learning project platform release. You can specify the zone where you want the virtual machine to reside. It's usually a good idea to choose a zone that has the least amount of latency to you, but you can usually just pick any zone where resources are available. And up here is the instance name that you give to the virtual machine. So this slide is similar to the previous slide where you could see the cost estimate on the screen before you created it. But unfortunately, if you go with the command line tool, you're not going to see the estimate. But if you're constantly creating virtual machines, then on the one hand, you'll have an idea of what the monthly cost is. On the other hand, what you really want to do is just quickly launch your virtual machine and get on with it. So we mentioned that the two solutions are deep learning virtual machines and notebooks. So notebooks, on the other hand, are a hosted version of Jupyter Notebooks. So again, just think of Google Colab. And typically, you can just launch this and you can start working without thinking about anything. There's nothing to learn if you've worked with Jupyter Notebooks, and even if you haven't, it's still easy to get started with AI platform notebooks. They're similar. They're scalable and cost-effective, but you don't need to worry about managing it yourself. All I can say is it's an awesome environment because I work with it personally. You're able to, within the platform notebooks, you have a virtual machine of your own. You're able to upload training data if you want to. So, let's say things that you'd use for testing your code before pushing onto the larger cloud for cloud training and deployment. You're able to host them in there. You're able to have multiple IPython notebooks. So just think of them like tabs where you're working on different code snippets. You're able to upload various scripts, Python scripts that you want to work with. So think of classes that you might have written. You're able to work with all of these without having to worry about any of the hardware. So it's fully managed. So, like I mentioned, if you launch notebooks, it gives you a compute engine instance. So it actually runs on the deep learning virtual machine, but all of that is pre-configured for you. Now, if you're working from the Cloud Console, this is what you see. It's called one-click deployment. You simply just go to the AI Platform Notebooks tab, and you'll have something similar to this, and you can simply click on Create Instance and specify what you want. So examples are, without GPU or with GPU. You can specify the number of processors, the amount of RAM that you want, and the rest of it is just handled for you pretty easily. Now, because on GCP, you can always choose to work on either the Cloud Console or the command line tool. You also have this option, although it's still in beta, so you need to specify beta, but you can use the command line to create a platform notebook. So you can use this command, specify the location where you want it, again, specify your image name, your image project, and machine type. So machine types in GCP specify combinations of CPU and RAM. So you have standard, you have high memory, and you have high CPU type machines. So this just specifies the underlying hardware that you're going to be working with. And then specify the location and give the notebook an instance name. And before you know it, you're off, and you can just start coding once your notebook is ready. It does take a few minutes to launch it, but once it's launched, you have a link besides the instance name where you can click, and it just opens up a browser tab, and you're off. Okay, so let's quickly jump to training your models once you have your infrastructure up. So on GCP, you're able to push training jobs onto the cloud and come back later to find out what the result of training is. Now, the primary advantage of this is the fact that training models can take time. Sometimes it takes a few hours, sometimes it takes longer than that. Now, in the traditional environment where you have to work on your hardware, what it means is you have to keep the hardware powered. But nowadays, lots of people just work off of their laptops, they connect to virtual machines, and they get their jobs done. And that's how you might, for instance, work with AI platform notebooks or deep learning virtual machines. You connect remotely from a laptop. The laptop doesn't need to be very powerful. All of the compute resources are made available from the compute engine that you're connected to remotely. But how do you run a training job for hours or days? You're going to have to disconnect your laptop and go off and do something else. So GCP has mechanism where you can push a training job. And so what you see here on the screen is that there's a jobs tab, and you can always go there and see what the status of the job is. If it's completed, you're going to see something like this. And with AI platform jobs, you're able to send two types of jobs. You're able to send hyperparameter tuning tasks in which you specify your search space for your hyperparameters, and the result will tell you what hyperparameters returned optimal results. And then you're able to send full training jobs. And the difference between a hyperparameter search job and a full training job is usually that with hyperparameter training job, you have a much smaller training and validation data set. So what you're trying to see is based off of certain combinations or permutations of hyperparameters, which model based off of a very small subset, maybe 1% of your entire training data, returns the best results. The full training job, on the other hand, will not have all of these options. You will then specify the particular hyperparameters that you've chosen or that you found based off of the first job. And then you'll give it all of your training data. And typically all of that training data will be in a cloud storage bucket or in BigQuery, but on the cloud. So when your jobs are done, you can come back, you can view the results of the job. And typically you would have specified where the model, the final model, along with the checkpoints will be stored. Again, it's usually on Google Cloud Storage. So from Google Cloud Storage, you're able to pick up your final model and use it for deployment and for serving. Now, in TensorFlow version 1, we had all of these same features. You could write your code and push to GCP for training. But in TensorFlow version 2, you're now able to package all of this into Docker containers. I'm not certain whether Docker containers were specifically used, if they were an option in version 1, but I never worked with them that way. But in version 2, you're able to bundle these into Docker containers. And this has advantages, as you'll know if you've ever worked with containerization. So you eliminate a whole bunch of things. Your code is never going to change. So whatever you arrived at before packaging into a Docker container is going to remain that way. You're able to push your Docker containers into something called Google Container Registry, again on top of GCP. Even the task of creating that container can also be pushed onto GCP. Well, so the steps for training a TensorFlow model would be, first, you develop your TensorFlow model and the training code that you'll do locally. You could do that, say, on AI Platform's notebook. Next, you create a Docker file, and you package your code along with the Docker file. Third, you'll build the image. Now, this you can push onto GCP. Then next, you push your container image onto a Google Container Registry. And then finally, you'll run some code, some commands, some instructions that will start your AI platform training job. So here's a very simple example of the first step. In the first step, you create a TensorFlow model. This is using the Keras API. So on the left, we'll have a model.py file. And so this can have your model definition, which you would have tested to make sure it works, it does everything you want to do. Then you'll have a separate Python file, which is the task, and this has your training code. So if you notice here, you'll have your model.fit, and you'll specify your training data sets, and all the other things you need to specify: steps per epoch, number of epochs you want to train for, validation data set, the verbosity, and any other callbacks. Callbacks are really awesome. I hope at some point in time you get to experience callbacks. Callbacks help you implement things like early stopping in your model. So you don't just keep training if you've hit your evaluation metrics that you're interested in, then callbacks can help you stop. Callbacks can help you do, say, this TensorFlow callback, for instance, will help you visualize your training as it's happening using TensorBoard. This learning rate decay callback will help you change the learning rates based on the epoch that you are at. So if you're training for 100 epochs, but you don't want to use the same learning rate across, then learning rate decay callback will handle that. Lots and lots of things that callbacks will let you do, but enough about callbacks. So once you have your model and you have your task, so your task will do all of the heavy lifting, you're then able to create your Docker file. And creating Docker files is pretty standard. Only thing here is what's your base image. And so your base image should be this. And if you recall, when we were creating AI platform notebooks and deep learning virtual machines, we saw this definition there. So this is your base image. And so the operating system with the libraries that you need and everything will come off of this. And then the rest of it is your standard Docker file definition, your working directory, instructions to copy your code files to those locations, and then you specify an instruction. And the instruction here is just to execute Python and to run it on this file task.py. So whenever your Docker file is launched, this instruction, this entry point, will be implemented. And that's really it with your Docker file. So third is build, test, and push the image. So you're able to call this to build your Docker file locally and to test your Docker file locally. Now, once you have your container, so unfortunately, these slides do not show actually building the Docker file on GCP and deploying to Google Container Registry. But you can easily find that out by just searching the Google Docs. And there are also lots of blogs. I think I even have a blog post about that. But check the Google Docs and you'll see how to build and deploy your Docker container to Google Container Registry. So once you have your Docker container in Google Container Registry, and this is the path to it, once you have it, it will be in gcr.io/your project name / your container image. You can then call gcloud AI platform jobs submit, and you specify that this is a training job, and you give it a name, specify the region, specify your Docker container image. You can pass a command line parameter. You can pass multiple command line parameters. So in this case, this command line parameter that you're passing here is the learning rate that you want to be used for your training. So if you want to have hyperparameter tuning as part of your container, what you'll do is you'll create a config.yaml file. And this is what it looks like, but the docs will go into greater detail as to what and what you can put in there. And then in your task.py, you will add a parser.add argument. So parser will read the command line. And so in this case, this example is where we say add an argument called LR, which we then utilize when we run the training job. So You specify the type. In this case, it's floating points. You specify a default value. So if it's missing, if it's not specified in the command line, what should be used? So the advantage of this is that you have your default values, but then if you're launching different jobs, you can specify different command line parameters, and then they'll override your defaults. And so once you push the job to GCP, you're able to go back and take a look at your jobs. And so this is what the jobs window will look like. It will show you all the jobs, whether or not they're running, the job type, is it training or is it hyperparameter tuning? And you can see in this case, it says hypertune is no, custom code training. You can see when the job was pushed, how long it took to run the job. Of course, this is a lab example, which is why it would complete in 6 minutes. And then you can always click the job name to get additional information. Training input, you can see the JSON for the input and output and other things. So once your job is done, you will have your model stored somewhere on GCP in a bucket that you specify typically. Now, something else that GCP is able to do is it's able to serve your model. And the reason why this is huge is because, again, you have, well, different options for serving model. So one is to say, take your model file and then write some Python Flask code to expose some API endpoints that will then invoke your model and run inference and return results. This is fine for very small jobs, but then think about it this way. If you have a model that needs to serve variable workloads, so on some days, at some points in time, maybe it's serving 100 requests a minute. At some points in time, maybe you need to respond to 10,000 requests a minute because the load varies. Then there are two options. One is you get a really large virtual machine that will be constantly able to respond to 10,000 requests, but then has wasted capacity if you're responding to 100 requests. The problem with that, of course, is that every business hopes to scale. And so what happens when you suddenly need to start responding to 20,000 requests? So that approach of just having one compute engine isn't going to do. Of course, you could argue that you could get a compute cluster, configure that, and do all sorts of things. And that is true. But there's also TensorFlow serving. And what TensorFlow serving does is it will give you a Docker image that you're able to deploy and scale on something like a Kubernetes cluster. So that goes back to that whole clustering argument. But sorry, did I skip? Yeah, okay. So, but you also have TensorFlow, AI platforms serving, which is native to GCP. So you don't need to worry about infrastructure. What you can do is simply just go and create your model deployment and point at your model file, specify a version, and it just starts serving. So these are the steps to serving a TensorFlow model. First one is to create an AI platform prediction model. You can do this from the console or from command line. We can keep just saying this, but we don't need to keep repeating it. So typically on GCP, anything that you can do on the console, you can do from command line. And there are also APIs that you could call remotely. So 3 steps: create an AI platform prediction model, create a version for the model, and then point it at your file and then make predictions. So first, to deploy the model, you need to specify where the model is located. So if you do cloud training, you'll typically leave your files on a cloud storage bucket. If you train locally for whatever reason, you can still copy all of that onto a cloud storage bucket. So once you specify that, you can then create the model on AI platform using this command, this instruction. And then you can deploy the model to the prediction service. Okay. And so once you do that, you're able to make predictions. Now, to make predictions using TensorFlow serving, one option that you have is to make use of JSON files. And so the JSON file does what is essentially kind of like a batch prediction. So you're able to send multiple requests in the JSON file and you'll get your responses back. So this is an example of the JSON file format. You'll have a JSON object with essentially the dictionary name is instances, and then you can pass an array of whatever you're interested in. And so you would use this G-Cloud AI platform predict. You'd specify the model. You can specify a version if you have multiple versions and you're interested in using a particular version for prediction, or if you leave it out, it will use the most recent version, the active version. And then you specify the JSON file that contains the data that you're using for prediction. And so this is an example of a batch prediction. Now, what we just saw, the example of that batch prediction from the command line, is typically used for testing. So if you have the model up there once in a while, you want to test as a machine learning engineer or as a data scientist, that's how you would typically run your tests once in a while. However, for your software engineers in your organization, they are going to need to make API calls to that model that you've deployed. And so this is an example of making API calls from Python. There's also Java code in there if you're interested. So what you're going to do is you're going to make a HTTP post request to this endpoint, and you're going to get a response. There are things that you're not seeing on this screen, but they're in the documentation, so you don't need to worry about it. So in the documentation, you'll create that dictionary that you saw us use prior to that. You will connect and authenticate to the API endpoint. And so when you make the call to predict, you will specify the name of the model and the version, and then you pass as body your instance, which is like the JSON object that we created prior. And once you execute that, you can then read the predictions component of the response object that is sent back. And because it's an API call, you can do it from multiple languages. Okay, so we still have time, so I will take a look at model explanation. And model explanation is I could say it's huge, but it's especially useful for saying, why are we getting the kinds of predictions that we're getting? So typically, you know that machine learning models are not yes/no models. They are typically probabilistic. So they'll tell you, if you're doing a regression, for example, it will then say, this is the class, this is one class, and this is the probability that your input falls into that class, right? And so the question now would be, why do we have that sort of output based off of our input? So you're able to see, for instance, your statistics. So recall that before you start training ML models, you would have done some statistics on the data. You would have looked at the frequency distribution of your data, your measures of central tendency, measures of dispersion. Now, there's usually something called training serving skew in machine learning, which is to say that the data that you trained your model on might not exactly reflect the data that you're running predictions on a few months later, or sometimes even a few weeks later. So when you go to model explainability, you start to look at those types of things here. For example, what is the statistic of the training data versus the statistic of what you're using for your inference? And you see an example of that here, where you're looking at variances in there. There's also something called a what if tool that was released by Google a short while ago, and you can integrate it. It's directly integrated, so that's what we were looking at in that screenshot. So how model explainability works on AI platform is you'll build your image, and you'll deploy your image, and then you'll debug your model in a notebook using attributions from AI platform and the what if tool. So you can look at various explanation methods. There are various explanation methods that are out there, and there's usually a paper about them. Essentially, there's typically a paper about almost everything in TensorFlow. That includes different pre-trained models, includes optimizers, loss functions. There's usually a paper for all of those. So again, if you're looking at various explanation methods like integrated gradients or sampled sharply, you'll find a paper for those. They're supported for different types of things. So if you're dealing with image data, you could use integrated gradients. For instance, if you're dealing with text data, you could again use integrated gradients. And there's a paper for that. So if you want your model to be explainable, this is recall how you deploy a model to GCP. You now need to specify an explanation method, right? So in this case, it's integrated gradients that you're interested in. And once you do that, you're able to then ask for the model to be explained, and that would be using using G-Cloud AI platform, G-Cloud Beta, so that feature is in beta. That would be using G-Cloud Beta AI platform explain, and then you specify the model that you're interested in the explainability for, and then you pass in the data that you want to use for that model evaluation to then understand the explanation. So again, this is just an example of our data that we're sending in for the explanation. So the output would look similar to something like this, where you see things like baseline predictions, and then the attribute values. So these are essentially distances. So you can see distances and how different the different dimensions of the data impact the prediction. So there's a standard prediction, but then based off of these dimensions, these features, the distance and the start hour and things, they either subtracted or added to the baseline value for your final prediction. Okay, so yeah, I'll quickly take this. I still have a few minutes, so I'll quickly take TPUs and stop. So TPUs are similar to GPUs in that they're application-specific integrated circuits, but they're different in the sense that GPUs were originally designed for graphics type computations, so that they were designed for computation and rendering in physics engines and things like that. TPUs, on the other hand, are specifically designed for machine learning. So when you create a virtual machine, you're able to request a TPU on GCP. But how do you update your code to work with TPUs? So to do that, you need to configure certain prerequisites, and then you need to create a TPU node, and then you need to make use of the TPU node from GCP. So typically, TPUs are not enabled on your GCP instance on your project unless you request for those. And the way to do that is to enable the API. So what that does is it avoids you accidentally creating these TPU instances and getting built. So you have to typically enable the API. So you'll need to enable both the Cloud TPU API and the Compute Engine API if you haven't done that. And then you need to enable Cloud TPU access to storage. So these command line instructions will handle all of those requests for you. Sorry about that. These command line instructions. So create an identity, grant it read access to Google Cloud Storage. So gcloud will run instructions for Google Cloud, or gsutil will run instructions for Google Cloud Storage. So here you grant access and for both read and write if you need to run updates on the bucket. Next, you need to set up your notebook and TPU servers. So here you create a notebook instance and you then create a TPU. And so what you need to do is when you create the TPU node, you need to use the same name as the notebook instance, and then they'll be attached. Also note that your location should be the same. Now, Google Cloud is huge on something called preemptible. What preemptible is it means that if there is greater demand for that resource somewhere else, it can be taken away from you. For the purposes of machine learning, if you are not in a hurry, that is fine because you will always checkpoint your model training. So you'll always checkpoint your model training. So if your training gets interrupted, you can always restart it. Now, the compensation for your training being interrupted for using preemptibles is that preemptibles cost about 20% of the cost of standard hardware. So it's good to consider preemptibles. Okay, so that's that with the setup, and then you can use the TPU in your training code. So what you need to do is get the IP address of your TPU node and then create a resolver. So once you've got your resolver, you can then set up your strategy. And what you do is you compile your model inside of your strategy scope. So that's the difference here. So recall that after the model definition, you need to compile your model and then you need to fit your model, right? And we had these in our task.py file for our Docker container. So what you need to do is to say, put the compile inside of a strategy scope. And our strategy here is TPU strategy, right? And so once you do that, you're making use of TPUs, and that's it. So I'll stop here for my presentation, and the slides will be made available to you by the organizers. Okay, if there's time, I'm happy to take questions.
Well, thank you very much. This was, well, quite extensive tutorial. And like one of our previous speakers, Randy Gupta, said, this technology is so working, it's almost boring. I mean, kind of, why not use it? Because with all the demand for the hardware that data analysts and data engineers are experiencing on a daily basis, when it's almost impossible to provide that kind of hardware for you, like always, it makes so much sense to use cloud. And there were some I would say types of companies and developers who do not concern using cloud for different reasons. Like one group, we can call them just greedy developers. They just favor having shiny thing in the box in the room with them, or maybe in the next room. They just want to see it whirling and like owning it, and that's something, well, not useful to discuss at all. There are those who are concerned with privacy of the data, especially since it all comes down to picking up a good data set for training, which is expensive, and it's worth a lot of money. So their major concern is like, I've spent so much time and so much money to build this data set, why would I share it? And I think that the thing is, you're not sharing it, you're just uploading it.
Yeah.
And Google recently actually showed a video about how thoroughly they create a security infrastructure with the data centers where cloud is running. Now, the other type of people, they are concerned more about money. And I'm not only talking about the money that is spent on running the training or inference. It's also money that is required to run the operation itself. Like, for example, we have a data set that is a few terabytes big, and we would have to upload it every other day. It would just cost a lot on a data transfer stage, and probably the running it in the cloud wouldn't be even the half of the price for that matters. But since you mentioned tensor processing units, I think it's worth mentioning that although they are very good at training, because some operations are more energy efficient and just basically faster, they really shine on inference, because inference on TPU runs so much better. So, well, I just have to say that I'm very grateful for you to join us, and I wish you a good day and stay healthy.
Thank you.
Well, we will move to the other speaker. Thank you.
Bye-bye.
So, before we move to our next speaker, who will talk about conversational AI, I just have to mention the question that arises in one of the chats about talking about Workly comparison to the startup that was showing on the stream. We have a policy here not to use our platform as a promotional platform. Like, if startup wants to talk about the technology they are using, we would gladly listen and promote that. Well, we will show that. But once you ask a startup a question, like how do they compare to some other competition of their own, they will eventually like end up promoting themselves, which is not what we want to do here. Now, with that said, I am welcoming Anu Srivastava. I hope I didn't mispronounce it too much.
No worries at all.
Happy to have you with us.
Yes, thank you for having me, everyone. I wish I could see everyone in person.
Is it good morning for you or good evening?
Good afternoon.
Good afternoon. Yeah, well,
Yeah.
it's all
Good
almost
evening to everyone on the stream.
Thank you for being with us. Now, we will talk about using conversational AI and how to make life better with that, right?
Yes, great.
I'm giving you the platform.
Thank you so much. Yeah, so I'll still be in the same vein talking about AI. However, I am talking about the API, so I'm actually going to be talking about Dialogflow today. I work in Google Developer Relations for Cloud, the AI and ML space, but for app developers. So we really focus on using mainly our pre-trained models and giving them to developers to integrate into their applications. So my goal is to target other developers like myself who maybe haven't studied machine learning for years, but I still have use cases that I want to integrate into my platform or application or whatever. So the title of my talk is Conversational AI with Google Chatbots, and I'm an engineer, as I mentioned, on Google Cloud. So let's get started. Okay, yeah, so here's my intro slide. I think I covered this. I've actually been at Google for 6.5, getting close to 7 years. I've worked in a few different parts of the company.
Excuse me, if I may.
Yes.
Your screen
I'm sorry.
sharing.
Let me make sure my screen is sharing. Thank you so much. Okay, great. Can everyone see that?
Yep.
Okay,
Good to
perfect. Yeah, so let's get started. So yes, this is who I am. I've been at Google for a while. I've actually worked in a few different departments. I started out in Android. If you have been an app developer, I worked on GMS Core, a lot of our core services. Then I was working a lot with cloud, so that's how I made the transition to cloud. And then last, just fun note, I live in New York now, but I'm actually from Texas, where Beyonce is also from. So even though I work on one part of the cloud, I frequently use G Suite. So G Suite has actually just been rebranded as Workspace, just like less than a week ago. The reason why I really like working with these APIs is that they help me connect technology to not only other engineers. You can kind of use like Sheets or Google Docs or Drive as a way to connect to all people, all different role types that you might be working with. So you can really try to help as many people in your organization. So hopefully a few of these icons should look familiar to you, like Gmail and Drive. My role in developer relations is sort of to act as a gateway between developers inside the company and developers outside the company, getting feedback so we can actually make these products and the documentation better. So please send me any feedback that you have if you've ever used these APIs or things that you might like to see. So the agenda today. We're going to start out by laying out the foundation of chatbots, and I'm going to show you how to do everything programmatically, so how to write it from scratch using Node. Then we'll talk about how to make this really robust and more user-friendly, a more flexible chatbot using conversational AI, this service called Dialogflow. And I'll show you how to quickly get started by training Chat Agent to make the bot feel more human. Then, so throughout this, I'll be showing you some demos. I think it's easiest to learn by looking at examples. So why are we talking about chatbots today? Chatbots have been around since the 90s. Here's the Wikipedia page. And you've probably used some when you're maybe getting online support for a product or something like that. So why am I talking about them now? Well, companies and consulting firms, they've done a lot of research and have data on development for businesses. So they've actually started to realize that you can do a lot of the same things that you would do in a full mobile app, but in a chatbot. And the chatbot is much more lightweight, easier to deploy, easier to maintain. Not everything, but some things. So, you can kind of use both in tandem to really hit a lot of your use cases. So same thing, there's a lot of potential here. I think chat is going to get kind of like another moment in the next few years. So Google chatbots. So chat is all about communication, collaboration. This is the big point about, G Suite workspace when you're working with these things in the cloud. And, it's even more crucial to our daily work now that a lot of people are working remotely instead of being in the office or being on campus and working together in purpose. The goal of chat is to try to replicate these things online when you are working remotely. So now let's get a little bit more technical. So the main use cases for chatbots, there's 3 types. So the first one is asynchronous notifications. You need to push some information because maybe some state changed. One trivial example is like, let's say you have a bot that checks at 9 a.m. every day, whose birthday is it? And then pushes a notification to the room with a fun message. More realistically, let's say maybe you have a chatbot that monitors your bugs that you're working on because you're a developer. Maybe one of them gets escalated. Then you could have a chatbot that would ping you like, hey, some state changed. This is important. That sort of asynchronous notification. Then the middle one-off actions. So this is kind of what I mentioned earlier, where you can do sort of quick one-off things to sort of augment a greater system. So, like a project management bot, maybe you can quickly make a bug and assign it to someone, but those more complex interactions you reserve for your web application. The last one is query for information. So doing just some sort of lookup. The demos I'll show today are query type bots. So bots in Google Chats. They're treated like users, the UX around that. And the reason why we want it to be really easy is because, if setting something up, installing something is too hard, people aren't going to do them. So bots are kind of treated as users in this chat environment. You can directly at them to interact with them. You add them to chat rooms the same way you do with actual users. And the point is that we don't want the barrier to entry to be too high. So there are lots of different ways to implement chatbots. So the first one that we have is HTTP and webhooks. So this is basically you have an agreed upon URL that goes back and forth between the chat room and then your bot. And then you just have to make sure this can be anything, any framework that you want, any programming language, any hosting service. You just have to make sure that the responses are in a JSON format that Google Chat understands and will be able to present in the chat room. So this is the most flexible. Most of the bots that are implemented for this are implemented using HTTP and webhooks. Then the one that we have in the middle is Cloud PubSub. So PubSub stands for Publisher Subscriber. It is a real-time event streaming and messaging system. So you push and pull messages. PubSub kind of holds the messages for you until your client can pull them. So this is actually really helpful and if you're working around firewalls in different systems. So say you're developing an app for a school campus, but your server is actually somewhere else. Then we have AppScript. So AppScript is it's actually the quickest way to get a chatbot up. AppScript is a lightweight scripting language. It is JavaScript, but it has built-in libraries for Google products, including chat. AppScript is actually most frequently used with spreadsheets, but you can also use it for chatbots. And if you should do the quick start, like, you can get a fully working chatbot in less than 5 minutes working, and it deploys really nicely because it's all integrated. So these are all the backend options, and really for all of them, the core thing is, like, you just need to push some JSON to chat that is formatted in a way that chat understands how to display it to the user. So let's talk about one of the benefits, the technical benefits of bots. So bots are apps, but they are different. I don't know about you, but a lot of my pain points when I'm developing applications is authentication. Well, when you're working with chatbots, that's actually handled for you because the user has to log in to use chat. So you get around having to work with that headache. So on the left, we use OAuth a lot for authentication. Here with the bots, you don't actually have to worry about that as much. So I think we talked about this a little bit earlier with PubSub. PubSub, you can get started with it on Google Cloud if that's the route that you choose to go. But yeah, you're pushing and pulling messages. Cool. So let's start with our first use case. So this actually came up at work. We have a lot of different sales teams at Google, and with a lot of different account managers, there's a lot of people all working together, and things change pretty quickly. You have to keep track of who's working on what account. It can be hard to figure out if you have a question, who the right person is to contact. So internally, we do have a team directory, but that doesn't tell you like what people are actually working on, that week or so. And a lot of my job is actually directing questions to the right people. And, even before we were all working remotely, a lot of our work is done in chat, the communication. So a lot of different teams will have sheets kind of like this. This is all fake data, but let's start with just like a basic version of this. So instead of having to open a new tab, it'd be really great that if I want to look something up, I could just get it in a chatbot. So how do we do this? So for the question mark in that slide before, I actually chose to use Cloud Functions. I think Cloud Functions are very easy to get started with. They're part of our serverless family. So if you've used App Engine before, that's kind of one of the more flagship products in the serverless family that we have on Google Cloud. There's also a Cloud Run, which is it's a newer product than Cloud Function, allows you more functionality. But I like to use Cloud Functions for things like this. They are narrow, focused bits of code that you upload to the cloud, and then GCP figures out how to place and scale them for you. So this is why we call it serverless, because you don't need to worry about specific servers and configurations. I don't need to worry about the actual machines. I don't need to worry about like when you needed a security update, doing things like redundancy. You can scale it really easily just through the online console, which takes out a lot of the headache for setting up your own backend. So you trigger these by events. These events can either be HTTP. So this is how we tie it into what I mentioned earlier about an HTTP chatbot. Or you can actually use Cloud Functions for a lot of other things that tie into cloud actions. So like maybe you save a file in your cloud storage, and then you can trigger a function on top of that. So just wanted to mention that. Today we'll be talking about HTTP Cloud Functions, which is the most common implementation of this, but just wanting to let you know that you can really do a lot of different things with this. And there are many languages available, so hopefully there's one that works for you. And all of these use open source frameworks. So I'll be coding in Node today, so we'll use Express, but say you're a Python developer, well, your Cloud Function will be using Flask. So that is our server part. What's actually, going to be in the code? I started this in the Google Sheet. So I showed you that sheet, and we need to look things up in it. But how do we do that? Well, we would do it with the Sheets API. So this is an interface that allows you to do almost anything that you can do in the Sheets UI, but now programmatically. So we're using functions in Node. So this is how I get started by installing the package using npm, the Node package manager, into my local directory. And this package Google APIs, it has a whole bunch of other APIs in there. So you really get a lot. So just a really quick intro into Sheets. It's kind of intuitive. It matches like how you use it as an end user. So you have an ID, which is the same ID for your sheet in the URL. That's how you can copy it. I'm just showing you Hello World just to show you the look and feel of using this API. So and then you have your spreadsheet, and you index it using A1 notation. And yeah, so this is how you can get started with the Sheets API. So let me just go ahead and show you how this bot would work. So I'm in my chat room. So then I just go, I want to at my Node bot, which is actually I did it in another room. Node accounts bot. So let's look up the company Acme. Cool. So my code actually constructs a card to give back where it'll give me all that information that I need. So let's go back here. So this is what our first bot looked like, where we're kind of doing everything by scratch. So we start out with Sheets, then we have a Cloud Function, and then we connect it to chat, and then the end user. So I don't have like a short link for this code sample, but I do have it up on our public repos if you are interested to see how this is developed. Let's just quickly chat about that last part. So we have two options on how we want to respond. We can go with like a basic text response that looks like what you or I might type into the chat room, or we can utilize the framework to build interactive card responses. So that's how I was able to construct this box with a few different widgets within it. And you can add interactive features. So these cards is what you push your server to the chat room, and they're all just constructed by JSON. And what's great is that you don't have, like, it, contrary to mobile app development, it looks the same on all devices, all platforms, web or mobile. So it'll look the same if I'm on the go using my phone, or if I'm at my computer at my desk. So I mentioned there's a few different types of widgets. We have different types of text formatting. We have buttons, so you can like link to maybe your full app. There's images, links, etc. This is just an example, actually, I pulled from the documentation on how to format a basic card. So that was a great example on how to get set up with a bot, how to do it very straightforward. But I showed you like a very simple spreadsheet. I did say that this was a real use case. So I'm going to show you the real version of that sheet that one of the European sales teams uses. So I did scrub out the data, but this spreadsheet, as I mentioned, it's used by the Benelux team for keeping track of who's working on what accounts. And it looks a lot more complicated than that basic example I just showed you. The way that it works is that our teams are broken up into clusters. And then in each cluster, you have different types of different roles. So we have account managers, we have engineers, And everyone has different specialties that they might have. So we have like security and networking. And then your cluster is responsible for a few different accounts. So as I mentioned, I scrubbed out the data and I actually just replaced the company names with different Google products. So if you could use your imagination with me, that would be great. But so this sheet, I would look up and be like, okay, I have a question about the Maps account. Okay, so then I need to first figure out what cluster Maps belongs to. So it's cluster 1. And then, okay, maybe I need some account information. I need to figure out who the account manager is that focuses on one of the specialties, networking. So this is significantly more complicated. And when you're working with lots of different teams, they might all have their own versions, and you need to know how to use the sheet. So it has, like, I guess, more of a need to actually have a quick way to look it up. So you actually need 3 pieces of information to find out who you need to talk to. You need the account, so you know what cluster it's in. You need the role type, and then you need to know the specialty. So I could implement this bot the same way I did the one I just showed you. I could make the bot expect those 3 pieces of information in a certain order. But that could actually be really error prone for the user. Everything would need to be spelled correctly. It would always have to be in the right order, or, you know, if I want to be more flexible, it would make my code significantly more complicated. And as I mentioned before, if it's too hard to use, people aren't going to use it. So this is where Dialogflow comes in. We're going to make it smart with Dialogflow. So this is a conversational experience for the user. And this graphic kind of shows you what Dialogflow does. It takes the input from the user and it parses things out so I can use it as a developer. So if you just look at this example, I'd like to book a weekend in Paris for next month. Well, I can the pre-trained models that Dialogflow uses can parse that out into variables that I can use, like date, city, and duration. So Dialogflow is this, it's a SDK. It's going to connect pre-trained models, and then you can train an agent for your chatbot to make it more robust and more user-friendly. So we're going to do exactly that for our spreadsheet lookup bot. So Dialogflow is going to sit in between the spreadsheet and the chatbot, and it's going to make it easier for both the end user and me as a developer. So what do I mean by conversational agent? Honestly, these words meant nothing to me before, a few months ago, before I started using Dialogflow for the first time. So I'll just go through this, this example. So this is an example of a weather bot. So I say, will it rain today? That's essentially like, what's the weather today? As a developer, I can't code every single possible input so I could respond to it. That's why it's really powerful to use this. And then, you know, Dialogflow does other things where, like, if it has a typo, it can understand like what the user probably meant and also do translations. So all of those different types of requests. Will it rain today? What's the weather? Do I need an umbrella? All of those are essentially this GET request. Get me the weather for this location on this date. So that's what it does. It boils down the user input into a few variables that I can use to program with. So this is a lot more robust than just having a bot that says, give me the weather. So there's a few different main components of building a Dialogflow bot. You have the agent, and then you need to connect the agent to what the user's intentions are. So that's what we call intent. So your code is all going to be wrapped up into Dialogflow intents. And then once you set up those intents, then you get these variables that are much easier to work with programmatically. So some of the things that you get with Dialogflow, it's cross-platform. There's a web UI and a console, which makes it easier to manage things. It's all about machine learning. You get things like natural language understanding. You get speech to text and text to speech. The natural language understanding is pretty helpful, especially if you're doing a customer service bot, because you can understand programmatically how the customer feels, and then you can start to connect this. If a case comes in that needs to be answered by a human, you can really make a robust system like that. I mentioned spelling correction, that's helpful, and then the translation is also helpful. Sentiment analysis, same thing. You can understand the user's emotional state of mind. Text to speech and speech to text, this is helpful for accessibility as well. So I'm actually going to show this to you in reverse. I'm going to do it live though. We're going to start with showing you the chatbot, and then we'll break it down from there. So I have a different chatbot. This one is my smart account bot. Oops. Okay, so let's try to ask a question from the sheet. Let's do, who is the account manager on, let's say, Gmail for networking? Phew, okay. So notice I didn't capitalize anything, but I'm able to get back this card that I programmed with a few more pieces of information. Let's do another one. Who is the account manager for, let's just say one of my fake accounts is called Waymo. So this time, I actually didn't give it all the pieces of information. So I actually got a follow-up question because the bot knows, hey, I need one more piece of information to look up your request. So I need to give it a skill. So let's do security. Great. So this is much more robust than just throwing an error because you didn't have all the pieces of information that you need. So now let me show you how we actually built it. So to start a Dialogflow bot, you need to go to the console, and then you can create your bot. And then now you have your agent for that bot. So we're going to first actually start with the entities. So the entities are the nouns, special words that wouldn't be in the pre-trained model, the pre-trained conversational model, but they're words that are important to the context of the bot. So for us, we have words that are the account. So like Gmail and Waymo, those aren't going to be in the pre-trained model. So I need to tell Dialogflow about them. We have the roles, so like account manager and specialist. We have the skills. Let's just take a look at one of these. So like the skills that I have are like data management, security, and networking. This I think is really important for making the bot flexible and robust and understand humans, because I can be really kind with these. So I can define synonyms. So if I have, machine learning, it's going to programmatically group it with my AI and ML keyword. For G Suite, someone just says Google Docs or apps. Apps is the old version of G Suite. It's going to map it to G Suite. It allows fuzzy matching too. So if someone makes like a typo, I'll still be able to fulfill that request. So those are the entities. I first define the entities. Now I need to do something with them. So then we get started with our intents. So for every chatbot, you have to have a welcome intent and then a fallback intent. So a welcome intent is what's presented when a user first adds a bot or maybe says, help or hello. What's really good to put in the welcome intent is information on how to use the chatbot. So for this one, I didn't do that. This is the welcome intent right out of the box. You get, good day, how can I help you? But to make, especially when you get into more complicated bots, it's good UX to have the instruction to the welcome intent. Then I mentioned the fallback intent earlier. That's also if a user puts in something that the bot doesn't understand. It's a way to gather more information and correct the request so the bot can fulfill it. So those are the intents I need just to have the bot out of the box. But then I need to have an intent for the actual task that I want to complete. So for us today, that is called lookup Googlers. Okay, so lookup Googler. This is what's going to be the glue for actually looking up the person that we need to contact. So I'm going to start at the bottom here with action and parameters. So earlier I showed you the entities that we added. So those need to turn into parameters, and those parameters are the variables that we work with in code. So I converted all of those nouns, and Dialogflow converts them into these entities, which are the variables that I'm going to get in my code. And then if you remember from one of my examples that I showed you, I didn't give it a piece of information that it needed. It needed the skill, but I didn't provide it. Here's where I can add a prompt to make sure I get everything. So, if the user forgets to specify the skill, I would ask, what skill are you interested in? Let's say I didn't specify the role type. You could add a prompt here for, the details. Do you want account manager or specialist? And these are ways to really make sure you get everything you need from the user. So those were action parameters. Then this is my actually favorite part, the training phrases. So you want to give the bot phrases that are what you expect typical structures from your user input. So what makes sense for your bot? And then Dialogflow digests these, adds them to the model so it can better serve your bot. So some of the sample phrases I gave it, like, please tell me who's the engineer for Brain, that would be an account. Please tell me who's an engineer on Brain. You really want to make sure you get the nuances of the language. So you can type it in, and then Dialogflow will guess what the parameters should be, and you can tweak this yourself, but that's how it does it. And the more training phrases you give it, the more robust it will be. So yeah, so this is all the setup. Where's the code? Well, you can actually have a Dialogflow bot that doesn't have any backing code, but ours, we need to connect it to the spreadsheet now that we have the variables and do the lookup. So we do that here in fulfillment. So fulfillment is how we actually connect a backend to this. So here I'm actually using Firebase functions. They're essentially the same as Google Cloud Functions. We're adding that library I mentioned earlier so I can talk to Sheets. And this is where all of my Node.js code goes on how to actually call and use a bot. So I'm not going to go through all the code. I will send you, I have posted the link. I have this all up on GitHub. But I implemented it to where here, where we start, we have this Dialogflow agent. And then within the agent, it gathers those variables that the user gave, and I can work with those variables to fulfill the request. So me as a developer, I don't need to worry about, what order the user asked for, the account, the role, the specialty. All I get back are the variables, and then I can look it up in the sheet with my Sheets code and then construct a card request and then present it to the user. So I will actually find where in here where I can show you where the agent gave me all of those different variables. Here we go. So we start with find Googler. This function, I connected it to that intent that I defined earlier. So the agent gives me all those variables, and I don't even really know what the user gave. Maybe they gave a typo, but Dialogflow normalized it for me, so it would be easier for me as a developer to fulfill that. And then while I was scrolling, you might have seen I have some code that looks like it's very Sheets-like. So these are the different areas, the clusters. Here are just some other things for this piece of code is how I integrated Dialogflow, Sheets, and Google Chat. So this will be at the end of my slides, and you can read it. Let me know what you think. Let me know if you have any suggestions. And this is how we were able to glue all those things together. Okay, so back to the slides. Oh yeah, so this is just what I showed up. I just wanted to show that this is really the core of what Dialogflow is doing. It's converting some input text into some variables, and then you're free to use the variables however much you like, so in whatever way that you like. So that's the use case it's hitting is it's converting, unstructured, flexible user input into variables that I can use and actually work with. So yeah, here's a GitHub link for where the code is. And I actually posted in Dialogflow, you can zip up your chatbot, the configuration, and then upload it into someone else's Dialogflow console. So I actually have the configuration for this chatbot in a zip file. And there's a place in the Dialogflow console if you just want to drop it in, and then you can just quickly get started playing around with this chatbot. So yeah, just a little bit more about intents and designing chatbots. So this chatbot, it is actually pretty simple compared to most Dialogflow chatbots. It only has one intent. Most production enterprise scale chatbots, you have multiple different intents. You're going to have a lot of different training phases, actions, parameters, and responses. But you can chain all of your actions in the agent with all of your intents. So let's say I had an example I talked about a little bit earlier, like a project management bot. So maybe some of your intents are like closing a bug, gathering information from another system. You can do lots of different actions, and then you kind of group those actions as intents. One of the examples we like to use is like if you had a bank account bot. So maybe one intent is checking the information on your account, but then you could chain that to another intent, like checking the balance. So if you're already familiar with Dialogflow, the Dialogflow library and cards, that should actually the cards should look familiar. I guess cards are a common concept in chatbots. Dialogflow has its own cards, and then Google Chat has a different set of cards, but you glue them together with the Dialogflow custom payload functionality. So this is a very important bit of code if you are implementing chatbots for different platforms. You just need to specify, what the platform is, and you can actually do this multiple times if you have one bot serving many different types of platforms. So actually, let me go ahead and share that really quickly here in the integration. So I can use this same chatbot to serve different platforms. So that's another big win for a Dialogflow. So you get Google Assistant right out of the box, but there's some enterprise chatbots that you can integrate with. Here, Hangouts chat is enabled by default, but let's say I wanted to serve Slack and Facebook Messenger with the same bot. My code would just have different implementations of the custom payload, and then the agent knows where it's responding. So the agent knows, okay, if I'm responding in Slack, take this bit of code constructed for Slack, or if I'm responding in Hangouts chat, it would take the part that looks like that. So that makes it easy to serve different platforms with your kind of one backend system. Something neat I forgot to mention earlier in the console is, like I mentioned, you get Google Assistant for free. You have this little thing on the side where you can actually test it out as you're going. So I can put here, like this is one I ran earlier. I can just test out a query right there, and it'll show me the response, and it'll show me the breakdown of what it's done. So I think that's really helpful for debugging and development. You don't have to wait to deploy a chatbot in your client every single time. You can just, especially when you're just tweaking things, just test all your changes in the console. So let's go ahead and recap what we built today. So we started with a tool that our coworkers were already using. They're using the spreadsheet. One of the reasons why I think it was important to put it in a chatbot is because, especially when you're working with a lot of different teams, you might have to remember all these different spreadsheets. Then you need to open a new tab and load it. Well, just by using Cloud Functions or Firebase functions in this case, and then this is Dialogflow, and we stick it in chat where our coworkers already are. They're already doing their work, and when I look up this person, the next thing I'm probably going to do is open another chat window to ping them whatever the question is. If you noticed earlier, I had some images in my card response of their office location. That I actually thought it'd be kind of fun to integrate the Google Maps static image API. So this is a neat API that's really easy to get started with. But you can construct a URL request for a location, and then it'll just give you back that image. And then you can embed it. I embedded it as an image widget into my bot. But the point is that you can call many different APIs in your fulfillment code. If I were doing if I was showing like the internal version of this, we use Google Contacts for everything. So that's how I would get like the email address and the office location. But say you have other services that you want to work with, you can call all of those APIs in your fulfillment code. So here are some links to get started today. Again, feel free to tweet at me. The Dialogflow version of the bot is available at this GitHub link. Here are some quick starts. These are the same quick starts I use to get started. I hope that you have some ideas on different apps that you can use to help whatever groups that you work with. And I look forward to hearing from you. And please post any questions that you have. I have a few minutes to answer questions.
Thank you very much. And I do recommend our viewers to check out Dialogflow. It's a really powerful tool that it doesn't only support like text analysis. It has text-to-speech, speech-to-text, sentiment analysis, even small talk support. But there are just a few things that it doesn't support yet so far, which are our local languages. Mm-hmm. One of the reasons we kind of like play test it and then keep it out of the way, because even though we have a lot of usage of Russian language in our Central Asian region, you see there is a difference between regional dialects, so to speak, and just like Dialogflow supports English as a, not just English, but Canadian English, American English, English in Great Britain, and so on. We are waiting for more regional support.
That's really good
maybe
feedback.
You can give
I'm
us
write
insight.
that down.
Maybe you can give us an insight, like what kind of well, I guess that the main priority is set to the user base. But anyway, maybe you are waiting for some community support from the region in order to provide you with some natural language processing data, and so on.
Oh, interesting. Yeah, actually, I have a question. Do the Google Cloud speech-to-text and text-to-speech APIs support more Russian dialects?
Well, they do support Russian in general.
But not the dialects, the same breadth that you have for other languages?
It will have issues once implemented in Central Asian countries. Like, the further you go from Russian border, the more, like, generally speaking, because there are certain like things that, well, not even dialect, maybe just the way we speak, maybe accents, so on.
I'm Indian, so I understand there's a lot of different regional dialects that aren't supported by these technologies. That's really good feedback. Thank you.
Okay. Well, thank you very much for your time. Thank you for being with us.
Thank you for having me.
And have a good day.
You too.
So we are done for today. Thank you everyone for being with us. And don't just leave yet, stay a while for a little more. We are going to show you the agenda for tomorrow, because tomorrow we have Flutter development sessions for half of Sunday. So be with us tomorrow. Come to the link that will be shared in the chats and in the comment section after this stream is finished. See you tomorrow. Have a good night.